Sure, when you're looking at the positions on the panel, if they're going to only one position, you can probably guarantee that's just a 21 breaker. You know, if it might be a 15-1 breaker, but you know it's number 12 wire. Okay, so you want to make sure anytime you see that any of the home runs are going to anything other than one position on the panel, it's probably a different type of wire configuration. So you want to look at the panel directly, you want to look at the plans, you want to try to look at the notes if there are notes to tell you. There's a number of these, right? 95.1 is going to panel M at 3 positions. Okay, and so you want to make sure you know the wire associated with those positions in your home run. Okay, and so that's our kitchen, and of course all of our symbols related to everything. So if you're not familiar with your symbols, print them out, because depending on the electrical engineer, they may use one symbol you think is something and it's something else. All right, so HVAC power, right? So this is a pretty good set when they separate the HVAC power. So you know any of the mechanical equipment is going to have disconnect switches that are associated, so breakers and disconnect. So you want to make sure you have all that accounted for, and all the wiring and all the home runs. And remember, all the mechanical equipment is on the ceiling. So, and my rule of thumb is this: when you have one piece of equipment that you're accounting for the conduit and wire run, 3 or 4 rooftop units, my rule of thumb with like all of the other general purpose, wire, even the home runs, I add 10%, because it's always a lot. So adding 10% usually covers your vertical measures, because this is all about the vertical measure. So, but when we're talking about rooftop units where we only have 1, 2, or 3, you want to add that vertical measure in with that individual measure. And I typically give the exact length of that power home run for that piece of mechanical equipment. So if we have 5 rooftop units, I'm going to have the power run for rooftop unit 1 through 5 plus the at least 10 feet down to the panel, right? So keep that in mind for your mechanical equipment. When you have a lot of home runs and you've got 3,500 linear feet of home run, adding 10%, you probably have your vertical measures of those home runs covered. But not so much when you're just running one piece of equipment or 2 or whatever. So make sure you include that. All right, so and then the next thing, of course, in your power plan, you're going to be looking for your single line diagram. How many panels, how many positions in each panel, because based on how it, is it 12 positions, 15 positions, 36, 42, 84, that number of positions, your labor's gonna depend on that. So of course you're always gonna account for all your breakers, and then look at all your panels and account for those breakers, and count each set of breakers in every panel. And then 2, if you have anything more than a 21, you probably have some type of special other than number 12 home run. So you really need to be, especially for the rooftop units and stuff. Okay, so what do we have? Takes up 3 positions, 83, 53, da 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 da. Bubbles, what do the bubbles mean? It's been a revision. Okay, so all of the panels, like 42 position, general purpose, right? Mostly 21s, all your outlets and stuff like that, or lighting, or okay, and single line. So we have to see, we need our power feeders, all of these. So we have to go back to the power plan and measure the physical distance from the main distribution panel to each one of those panels, because the single line diagram is not to scale. So this is a new one we're doing. We'll have it done tomorrow. Make sure you look at all the basics of the electrical. Make sure you join our master's program so you can work with us on our stuff and also your own. Make sure to like and sub, and I will see you next time. Hey everybody, in this video we are going to review the site electrical for our new from the ground up restaurant. So first thing we always do is, well, we have some building lighting, and they broke it out like this for some reason. Usually they use those symbols for mechanical equipment. So these lights, this little thing right here, that's SW, and we have a number of those. And then we have, it looks like some emergency lights. We have those. So we start by counting all the lights, and you see we have some also some. Well, let's go back. We have 2 buildings, site electrical, 2 buildings, and this is like install conduit for future property split. So we did the building lighting, exterior lighting, all of the dots, and then we have some EV chargers. Very good thing, very good investment. Electric vehicle chargers. Within 5 years or something, we're going from 7% electric vehicles to 25% of Americans driving electric vehicles in just a few years. So very good investment to, even in your own home, put an electric vehicle charging system. I was talking to a GC too that I'm working with. A lot of good ideas now that a lot of good ideas for home systems, whether it's a home medical, well, it can't be medical, but a home growing room, whatever you want to grow, as long as it's legal, and EV chargers. Nice side hustle for any construction firm if you're into that. So yeah, so they're going to install some EV chargers here, but what they don't give us is, they say, and we have some revision bubbles, so they've already revised this a couple of times, but it doesn't give us the location of the EV panel. It does a pretty good job of showing us here as far as the panels within the building, panel 1, panel 2, and L, but nowhere on the plan does it show us where the EV charger is, and we have to run 1-inch conduit to the EV charger, and also to EV charger panel, I should say, and they don't show us where the panel is. There's nowhere on the plan. And then we also have to run it to this panel H2. So, you know, with a site plan and so much linear feet, you know, you don't want to guess where the charger panel is, so you need to ask before we get to running this this conduit from the EV charger. So that's something that we're not going to do, because if they're over here, then we're going to be short. If they're over there, we're going to be short or long, depending on which one. So those are things you'll stop and you'll ask before you just assume where it's at, or just exclude all of the 1-inch underground conduit for the EV chargers, because you can't guess. And so know that all the wiring, all the lighting, it's good. It's giving us, usually your exterior lighting is a number 10. Okay, and so it's telling us, and here it's a number 8. So it's telling us those are the wires that we're running or we're powering each of the exterior light poles, or what this is. These are. And then it shows us the light pole configuration. Okay, and you know, this is the concrete, and we've got the, you know, this is how it's designed. Okay, and this is our light. So we're actually bidding this one, so I'm very excited. Okay, so that's exterior work. You know, exterior conduit is going to be PVC, and then we have to account for stub ups, right, near the, wherever the distribution panel is. We have to account for, is that once it stubs up, is it rigid steel, probably at the exterior of the building. So rigid steel, conduit, much different in pricing than EMT, so, or especially PVC. So that much we gotta make sure. So next we're gonna come up with the building lighting plan. It's messy, it's big. We're gonna save that building electrical. So next we're gonna do the lighting plan for all the new lights inside the building. So make sure to watch the overview, make sure to watch the basics, and then we will be right back with the lighting plan, the power plan, and then go over the single line diagram for this project. See you soon. Make sure to like and subscribe. See you soon. Okay, everybody. In this video, we're going to look through our lighting plan and our power plan for our restaurant that we started the site work on. And so I just want to go over that very quickly. So of course, what we have to do first is to make sure that we count all of our lighting fixtures. It's a full list of fixtures. There's a lot of different fixtures and fans. And so we want to make sure we just click right, name stuff correctly. And then second step is to measure all of our MC cable that's going to connect all the lights. Okay, and so, just got to go step by step, measure all of that, and it's really simple when it comes to the lights. This set is kind of like, it's not too clear in terms of, they kind of mix stuff up here, like in this area, things are kind of mixed. It's like, okay, here's the light, here's the light. Here's one. I think we may, hopefully we're not missing something. And let me make sure I add some more. Because normally we measure all the lights first, or count the lights. And then we go through and measure all the MC cable, which we use for the branch or connecting the lights. And then the very last thing is going to be the home runs. And so we didn't do all the home runs in this yet, because once we do the home runs, it's going to be so messy you're not going to be able to see anything. And so lighting plan, series of lights. And as you can see here, they've had a bunch of revisions because there's a revision cloud of bubbles in here. And so, the hardest thing when we do the lighting takeoff is just to make sure we can identify each of the types of lights. And here they kind of did a little weird thing on how they named the lights. So they didn't put a mark next to each one, so they kind of clustered them all together. So, this is kind of annoying. And then we go to our power plan. Okay, so our power plan is, like every power plan. So we're going to make sure we separate if we have the GFCIs from the general purpose outlets, from the specialty outlets, which we will have anytime we have a kitchen. We have some specialty outlets. And same thing here. We do make all of our power wire measurements because they typically use MC cable. And so we want to get that first. And then we do all of the home runs. Now, when we come back and do the video for the home runs, you see the symbols different. We have the larger slash, two small ones, and then the larger slash and one. So we'll go over what that means and how we run the wire based on those symbols. Okay, so maybe a few things we have to change. And I don't know if you did review the site plan work that we did, or the video we did. We didn't know where on the site plan it didn't show us where EV was. We found EV, so it's here with all the other panels, which you never want to assume. And so looking at the building electrical cleared up what we didn't see in the site electrical. Okay, so what we're going to do is we're going to come back and show you all of the home runs now that we run from here. And so all of the main panels are here. And so when you run the home runs, just to make it easy for you as the estimator, You're going to start with the home runs that are closer, and I say this all the time. You're going to make the measurements that are closer, 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 and then you start to work your way out. Okay, and then you just have to have a good eye and figure out, if you want to work from this end that way or this end that way. But home runs are very identifiable, so you know what it is. And also you want to also make sure, because electrical is so detailed, right? You have your general purpose wire, you have your lighting wire, you have, if it's a kitchen, some of the receptacles have different wire configurations depending on that piece of equipment. Then you have your HVAC wiring configurations, because it's going to be different. So you want to make sure that you separate, for the purpose of helping your electrician understand that you have everything that they need to make sure they understand that you've done a good job. So you want to separate all of your MC cable lengths from all of the links for all the individual mechanical equipment. So if you have 4 rooftop units, you're going to give them well, I do, just to make life easy, and I win a lot, right? So, and 2, that helps them to see if there's something off about your calculations, and that's what I'm like, hey, I'm just giving you the measurements that are on the plan. I'm giving you the wire configurations that are stated. So I want you to be able to have a clear picture of what I've measured. And so, yeah, when it comes to your power plan, you want to, again, have your different totals for your MC cable, for your mechanical equipment, each run individually, exhaust fans, rooftop units, condensers, whatever it is. Okay, if you got 20, you need 20 different links, and I call them relevant links. Can't talk. It's 10 o'clock, 9 o'clock. We start this at 4 in the morning Pacific time. So we call it relevant links. And so I give all the list of all the relevant links, and then all of the links of the home runs that go to each of the panels. And so in the next video, we're going to go through, I'm going to do the home runs, because this has to be submitted first thing Friday morning. So early in the morning, I'll be doing all of the home runs, and then I'll come back and show you the mess based on these home runs, so you can see what the final product. And when I talk about the home runs, I always say, you're not trying to give your electrician a exact, you have so many feet. You want to give a good representation based on the plans, that if you go from this home run to the panel it says it is connected to, that you are representing that actual length. Yes, because these plans are to scale. That's why they're to scale. And so the distance from this home run, or this outlet in this home run, to position 1, 3, and 5 in panel P1 is the length that I measure, because the plans are to scale. And so the electrician may run it a different way, but again, you want to be able to ensure that your measurement is a reasonable representation of what would be there if you ran it that way. And so you add your 10%, you right on. Okay, and so tomorrow I will show all the home runs that we did perform here on this set of plans. And again, if we did it now, it'd be too messy. You wouldn't be able to see anything else. And then another thing we did is all of the panels in the single line. Okay, and then also in that next video when we do the home runs, we're gonna, because you have the single line, but that's just showing you the power in one line. It's not giving you any indication of the actual distance for the power feeders. So what do you have to do? You have to go back to the power plan and measure the actual distance from panel L to the main distribution. I always give myself at least the farthest distance away. And so from main distribution to the EV panel is this length. Then main distribution to panel M, main distribution to panel P1, all the way down. Okay, and so main distribution and all the panels. Okay, so that's what you would be doing. And then the 1 and the 2s represent the power feeder from the links that we just measured. Okay, and so make sure you make that correlation. The single line is just to show you in one line all of the power coming into the building, all the panels that you'll have to order, and all the feeders. And then, of course, we did all the counts for all the breakers that go in the panel. And this switch gear came to $38,000. We just got it today, and we'll be bidding on this tomorrow. We still need the lighting package. Okay, so make sure you watch the site plan review that we did, and make sure you watch tomorrow so you can see all the home runs that I run for this. And then a little later we're going to have a Hampton Inn overview, HVAC overview, because today is for HVAC, still not finished, and I never go to sleep until I finish all my work. So please like, please subscribe, tell me what you think, and if you have any questions related to what you do, make sure you let me know. I'm sure I can answer your question. Have a good night, and look for that HVAC coming up real soon. Hey everyone, this is Stacy. And what we're going to do in this short video, we're going to have a complete overview of the Hampton Inn Electrical to show you how we break it down, what the plans look like, and how we're going to attack this one next week. And so we're looking at the good old cover sheet. But what we want to focus on are, this is the floor plan, first floor plan lighting. Now, when it comes to hotels, sometimes, what's best to do is, this one has 5 floors, and it looks like floors 3, 4, and 5 are exactly the same. And so basically just 1, 2, and 3 are different. No, 1 and 2 are different. And then 3, 4, and 5 are the same. And so what you can do is just do 3 and multiply it by 3. That way you save yourself a lot of time, whether it's the lighting plan or the floor plan, or the lighting plan or the power plan. And so this is the first floor lighting plan, and usually on any hotel first floor you're not going to have anything but offices. So it's the lighting plan for all of that. The next one is the parking deck lighting. Okay, so for the parking deck, and then the second floor lighting plan. So here for the individual rooms, because the second floor has individual rooms, we're going to go and look at each of the, just like before, just like everything else, we're going to look at each of the individual models, do the takeoffs for as if we're doing a small room, and then multiply by the number of that type of room that's in the hotel. And so second floor, here's the second floor, so it's just a bunch of counting and then doing your MC cable for your circuitry, connecting your lights, so that's pretty easy. And then count all your switches, occupancy switches, as opposed to any of the other ones that might be here. Okay, and now this is the third floor. Okay, so third floor is all hotels and the common things that are on each floor, the maid's room, and then all the hallways, of course, and then storage in the corridor, all of this. Maybe not this outside area, but I'm gonna have to take a look. Okay, so that's the third floor. So let's take a good overview of the third floor, because if it looks, all the other floors look like this. It may look like this minus that, but let's take a look. So this is the fourth floor. Okay, let me go back to the third floor. Okay, third floor, this is there, storage, guest laundry, corridors. Okay, so that's the third, and then this is Okay, because I want to do a visual to see if visually it looks the same. Minus this. Okay, so you could just do that by itself, and then do 3, 4, 5 if it's the same. Let's see. So there's 3. Yeah, it's the same minus this, and that's 4, and this is, and then 5 brings it back again. So do that separately. Multiply that by 2 because you have it on 3 and on 5. And then save you time counting all of these 3 times because it's all the same. All right, so here is the power plan. First floor, and it's going to have some call outs. So we have to go to the call out for this area. Okay, that's probably this right there. So first floor, power. Then the parking lot deck, power. So just a few things. And then we go into each of the floors. So the second floor. Okay, common rooms, all gray, so we're not going to have to do anything with that. So second floor, and then let's go into the third floor, third, fourth, and fifth, and see if we can do that multiplier thing with these floors. Let's go back. No, this third floor is much different. Oh no, that's the second floor. Let's go to third floor. Okay, third floor, fourth floor. Let's go back to third floor. Third floor, fourth floor, they look the same. But I would go in more detail to make sure, but they're the same. So I could do the third floor once. We don't have anything here, all that's there. Let's look at the fourth floor. Looks like something's missing there that was on the third floor though. Yeah, this right here. There's guest laundry on the third floor. It's a storage on the fourth floor. Is it a guest laundry again? And it's a storage. Since there's so little to do on the power plan for 3, 4, and 5, just do the power plan individually. But the lighting plan, you can do that. And then here's the roof. And so what we have to do is see where each of the rooftop units with the wire configuration, because the mechanical power feeders are going to be different, and then see which of the panels it's connected to, and then run it in that direction. Find the physical location of the panel and run it in that direction. Now, the pain in the butt part for hotels. Depending on how many different room styles they have, you have to do each one individually, but it's small, but it's still a pain. And so sometimes I'll do the biggest one in terms of wire and conduit, but it's still so small. It's just going to take you some time, but you can do it. So do each one individually. And we know we have 5, 10, 6, 12 of each one. And so we just do that math. And then we have the single line. The hugest, of course, the single line for a hotel is going to have all the main equipment, okay, in the basement or on the first floor. And then the panels that control each of the floors are going to be on that floor. And so what I normally do for a hotel, as far as the switch gear, I'll put everything on the single line in the common area estimate. So we'll have a few estimates. We'll have the common area estimate, so for all the common areas, not the rooms. So in the common area estimate, and in the common area estimate, I'd also put the site plan, all of that, but all that deck and all that, that's going to go in the common area estimate, so it'll be much bigger. And then I'll have one estimate for each of the units. And all of the single line goes on the common area estimate. Okay, and so what they're going to give you all, the lighting schedule. There's tons of lights in this hotel. We're also going to do the drywall and framing for this hotel, so that'll be a quick overview of that next. And then they give us the schedule of all of the mechanical equipment. Okay, and then the wire configuration and that's just perfect. So, of course, it's going to take you longer because you have this many pieces of equipment, but the goal and what you want to do and be a good estimator is that, yeah, you want to come as close to the physical length, how many linear feet from that mechanical piece of equipment to the panel that it's connected to. And so that's part of looking on your power plan. Okay, we got some other things going on here, so let's make sure we're good. Yes, and so last but not least, we're going to look at all of our panels and count all of the breakers and do all that good stuff. So this is just a basic overview, and we're going to break each of those items down individually, do the takeoff, do the estimate, man hours, and so make sure you join me for that, and just keep your eye out for good stuff, because we'll be delivering all weekend long. Have a good one. Talk to you soon. Hey everyone, okay, in this video we are going to go into detail on the small electrical for this project that I did pretty much everything else live. Hopefully you'll have an opportunity to watch that today, the 17th of January 2023. And join me live every day at 10 a.m., which I call the Construction Queen Live, and we're going to do something interesting, not just for construction, but hopefully to discuss current events and things related to construction, like, things like our country. And I said in one of my shorts that I think about construction like a good football team, right? No matter who's on the team, no matter the color, okay, no matter where you come from, where you're going, our goal is to win the Super Bowl, right? Football. I'm not really into football. My thing is basketball, but I mean, I'll watch anything. I love sports. I've watched dogs run around. I mean, that to me, that's sports. But I watch golf. Okay? And people say, you watch baseball? Baseball is what's up. Okay? So, yeah, I like baseball. But football, I'll watch. Because it's like, to me, it's like, it's like, y'all ready again? Let's get ready. It's like, man, run. Just everybody Hail Mary. Because is boring to me. All right, I just got to say. That's why I like basketball. It's moving, it's action. They jump in people's parts in people's face. I like that. Well, they do that too, but I don't like that. Anyway. Let's talk about this. Electrical. So what's our wonderful 3-step process? Always with the electrician, you want to get your set of plans and do your counts, right? Because you want to send those counts to your supplier, so by the time you finish the estimate, you'll have your lighting package back and your switch gear. In this case, it's probably a standard where you can get it from the cost book. Panel seemed pretty simple. So this is a new was existing retail something that's turning into a new jewelry store. And so they have a lot of low voltage, which is where your alarms are, and data points and all of that. That's low voltage wiring. So it looks like they have quite a bit of, it's a jewelry store, right? So they're going to have lots of sensor type stuff all throughout the store. And so this right here is showing me that I have some underground. That's what that looks like. It may be something else, but see, is this underground? No. Okay, I'm really into symbols and them being right. Okay, so I'm going to look at the keynotes to see what this is telling me, because broken lines, you are to assume they're underground, but I'm assuming this underground, that this is going from a column up the column in, and usually this is a quad floor data underground. It's going to tell us 52 and 5, low voltage 2, low voltage 5. Let's see what those are. Power plant, electrical power, here we go. Low voltage 2, point of sale system, 10 infinity pool, 6 cat 6 cables through GC provided conduit. Okay, so we need to know the size of the conduit. Okay, LV2, all of the 10. Maybe it'll tell us, because we'll just assume whatever size conduit we need for any of this, we're going to assume that's the size, because you should tell us what size conduit. Okay, so this is going to be a little stinker, but that's okay. Conduit 1.5. Okay, 1.5 inch. Cash wrap. Okay, so we're going to assume 1.5. We'll assume the bigger of the two. Electrical outlet, conduit, pull string, manager's desk, telephone. That's 53. Yeah, so they've got, you know, the keynote's kind of screwy. 52 is fun. No. Okay. All right, so the first thing we're going to do is we're going to count. We start with the dupes. Duplex outlets. This is a switched outlet. Let's see what 2 is, just in case it's something different. I don't know. Not for our purpose. And the 3s were 3 were ceiling. 2's not. 3's are, so I need to go ahead and this is a nice little, let's look at it again. Yeah, ceiling. The anchor for those are different. Okay, so I should have printed that out so I don't know what all of those are. Let's see what 57 is. Okay, so let's see. Let's make some sense out of. Let's do this. Let's see what 6 is telling me. Okay. Flexible conduit for that. Okay. So 5. Where'd it go? Oh, 6. Was it 6? Oh, did I read 5 or 6? Yeah, I read 5. Okay, but I really needed 6, but I know 5 is a flex. It's quad with flex conduit. That one is not. And 2. Okay, we don't care. It's the dupe. 2. And 2 and 2. 2. Do a little low voltage last. See what 11 and 12, just in case we need to center. Nope. Oh wait, what? Okay, nope. Dupe. 60. Low voltage 60. Where is it? Low voltage 60. Oh no. Low voltage 460. Tenants IT vendor pool. Okay. Alright, and now that's so stupid. And now we gotta go to 60 for whatever has a 60. Okay. That's stupid. 3. Oh, wait. Pull string. Don't say where it's going, but we assume it's going to the ceiling. So I'm going to say we need a junction box. Junction box first for data and phone. See, that tells me that I need, well, let's make sure, because sometimes we'll need more than a 3/4 inch. Okay, so that's that one. See if we, and then we'll do all of wall cam, ceiling cam, 59, junction box. Let's see. From the okay, so that's different. Now we have to run that to the telephone. I'm assuming the telephone is back here, but that may not be true. Oh well, unless it shows, it's usually back there with the panel. So now 59, we have to run 1 inch, 3/4 inch, 3/4 inch. Okay, let's make sure it's to scale. Where's the scale? There we go. Make sure it's to scale. You mess your life up if it's not to scale. Alright, so we need 3/4 inch conduit from there, from each one of our 59s, because the camera is running directly to whatever, so we just assume it's there. So everywhere we see a 59, we got to run it. That's for the cameras. 59. And over here. Let's see. 59 over here and over there. So I'm just going to say we run it this way on these. And 1 inch conduit. 59. Okay. So let's see what the other 59, 59, 59. There, here. We didn't get that one. We had 10% to those. All right. So let's see what 57. Oh wait, 57 LVA 57. We don't care about the LVA part. 1 inch conduit. From to this location from with pull string. Exact location. Sprinkler. Okay. 57 is 1 inch conduit. So yeah, gas stations, banks, anything with high value stuff in it. I mean, even, oh look, I missed that one. 57. I missed that 59. There. Let me do this 59 though. 3/4 inch. 57. 57, 57. There's one. So 59, 59. Okay, so we got those two. Still 1-inch conduit. Okay, so we're gonna go from here. Conduit will pull string. Basically, the price is twice the conduit price. We do it that way. And 55, 56, 55, 56, 54, 55, and 56. Probably the same situation with some conduit. There's a 53. Let's see, flash box and pull string. Yeah, everything. GC manager's desk, telephone, and equipment. Okay. So 53 is 1-inch conduit to the telephone board. 53 is. This place is wired up, let me tell you. 1-inch conduit. Then I have to do data phone outlet, J-box data phone. You know, because that's different than the other one. Okay. Okay, so let's see what 55 is. Let's just work our way. Yeah, let's see what 55 is and just finish out all of that. 1 3/4 from this location to so 1 3/4 inch from this location to location LV6. From this location to location LV6 right here. So let me read that again. 54. Okay. Okay, that 54 goes to okay. Wait. Okay, yeah, that's what I thought. So 54 goes to the backboard, but 55 goes to 54. Okay. So, and it's all 3/4 inch. Okay. So, I'm going to do just like that. That goes to that. And then that goes to this. Alright. And 56 does what now? Wi-Fi trying to GC at the location shown. Alright, so 3/4 inch more, 3/4 inch. I don't have nothing going from that one. I don't. Okay, now we can do that 52 and 5. I have to do 52 and 5. 1.5 to cash wrap. Surface mounted 4S glass box and cash wrap with 1 1/4 conduit and pull string to. Okay. And then 5. That's 1 1/2. And then 5 is. Okay, we don't care about that. That's just a quad. But this one is 1 1/2 to from here and then 2. Okay, got you. But 1 1/2, that's underground. Both of those are underground, and then up the pole, and then to the board and to the power. So we have to say underground power and up. That's this one. And then we say underground 1 1/2 inch conduit and up. That's this one. And now we say 1 1/2 conduit to telephone board, which is boom, boom, boom. And we're not doing the home runs for the power yet. Just getting this annoying LV stuff out of the way. Okay. All right, now we can do MC cable for power. So I just call it power wire. And then we do home runs. Okay, so we're going to run it like they run it, and then we're going to run it. Boom, boom. Oh, we got to do that quad right there. Run. Then what we got? Okay, so we have all of that, and what do we got? That's home runs. All these colors are getting mixed up. All right, so now let's do the home runs, and then that's it for this. Home runs. All right, let's do the ones that are the closest. This one and this one. There's 2. And then we got this one. Just gonna run it right there. We got this one. And we got this one. We gotta add that junction box in there. And then we got this one. Okay, so let's go in and add. We got this, the bar and then grounding most likely. Got the quad. And wait, I see the junction box I didn't account for. So we have J box power. Oops, fat fingers. Make sure we got all the home runs. Yep. Yes. Yes. Got all. It looks like we left out this junction box for the wall camera. Yeah. J box. all of the 59s. Final connections of all of the 59s. That's the wall cameras. Let's see what that is. 59 here. We got that. And that's the smoke detector. Oh, speaker. That's the speaker. Alright. And got this. Junction box. Let's do this. J-box. Exterior power. Exterior light. Exterior sign. That way I know to make it waterproof. And then we got this. I think we counted. We got that home run, but we didn't get that power. MC cable. This power and this home run. All right, so that is going to be, I got that. That is the full power plan takeoff for this small jewelry store. Make sure to look for, oh, nope, almost. Yeah, because we've got that disconnect. We got the existing, almost. So this would be the home run for the specialty wiring, and this is just the general power home run. Okay, and this is the existing rooftop unit. So in terms of its power, how we run it, this one we can just run as the home run. Okay, we have to add that, and then we're going to add, and we're going to add 10 feet to that. And then that's the home run. And then that, this would be the rooftop unit power. So, because we'll look on our power schedule when we put everything together, we have a little video for the panel only. We will account for that. This is on the roof. They just would separate it, and then we'll add 10 feet for that too. Okay, now, and then we'll add waterproof GFCI. And I believe this comes with the unit, not quite sure, and we just connect it. But the unit's already there, so, but we still add it because it looks like it's something new. All right, now that completes our power takeoff for this, and we will come back tomorrow with the actual estimate to show you all the great work to finish it off and how much it's going to be. We should be able to get good pricing, but we have part 2 and part 3. This actually has 3 more parts. One, we're going to come back with the lighting plan because a lot of people want to see them all separate because it does take forever. So the lighting plan we'll come back with, and then we'll come back with the panel schedule and how we're running the power feeders. And then last but not least, we'll put the estimate together. So look for those 3. Always make sure to subscribe and to like. Let me know what you think, and see you next time. Hello everybody, and I hope you are in for a very extensive overview of a nice set of electrical plans for a home to suites. And so what we're going to do, everything that I do is pretty much for the new electrician, someone that's really just learning how to review everything or been in it for a while. And because I think that any field of estimating, any form of estimating is an art. The more you do, the better you get. So hold tight, stay with me here in my initial basic overview of all the sheets and how we go about thinking about the electrical set when it comes to a hotel, because it is much different, because as you can imagine, you have common areas and then you have the individual rooms, and you really want to save a lot of time, because as we know, unless you know that you won the project, uh, this is time consuming, and so you want to use as many shortcuts as you can. We're also going to do this for all of the trades, and so we're going to have the basic overview here, and then we're going to have a more in-depth overview for our Patreon subscribers, and we hope you join us there as well. Okay, so what are we looking at? We're looking at the cover sheet for the electrical set, the E-set, right? And we know that this, you always want to make sure that your plans have been sent for approval, that they have an approval date, because that lets you know that the project's actually going to be built, and that they're not wasting your time just fishing for a number, which is fine. But you, as I always say, you want to know that, so you're not wasting a lot of valuable time giving them a detailed estimate, and they're just looking for really the cost of the project in full. So you always want to look for that. And as we know, the right band is always going to give you all the information, all the same information, and it gives us the project location, because like me, if you do projects in a lot of different areas, you want to make sure your pricing and your man hours, your basic rate is based on the physical location of the project. Okay, and so you always want to take a good look. 9 times out of 10, you're going to have copper wires going to be used, waterproof if they're going to be used outside, all of this stuff. And it makes a difference, because a lot of times I have seen on the plans that we'll have junction boxes on the exterior of the building, but it won't have the WP, the waterproof symbol. And so that's kind of common knowledge, that anything that you're going to use outside, you make sure it's a waterproof item. And again, how they get around having mistakes on the plans, well, they told you here in words, even if it's not on the plans. And so you want to make sure you look for that. And as always, and also on our Patreon, we go through all of the specifications for the electrical, the master format, and what number are we looking at if we have to install just the panels. Where in our mind should we be going in the specification that work, because we know that we look at the specifications first, and then we take notes from the specifications, and then we come to the drawings, and we take the measurements. The measurements help us determine the cost of the project, right? And the specifications that I went over in real good detail with one of my HVAC students, that the specifications are intended to give you information about the material, specifications of the material. For instance, for HVAC, what gauge sheet metal are you going to use? 16, 18, 20, 22. It's all going to be stated in the specifications. So they may take portions of that and put them here in the general notes, but it is vital that you read the specifications. Okay, and so let's see. All connections to mechanical equipment shall be made with a minimum of 24-inch of weatherproof flexible conduit to prevent sound and vibration transmission. That's important. And so this again would be in the specifications, but it's very important to make sure you note it, so when you go back and you're doing the mechanical power connections, now you're using flexible conduit for the final connections. 2 feet. Okay, so that's important. So what you can do, if that is the case, for each piece of uh, hmm, mechanical equipment. And in this case, in a hotel, there's a lot, right? Each room has its own private VPAC system, I think they're called. So that will become very important. So that's something that you really want to. It makes me think twice when I read through it. I'm like, have I always included that? No, but these are things that you want to make sure you don't make the mistake not to. And really, once you've made the determination in one set, it's probably the same with all the types of projects of the same type and kind. So, all right. Okay, so symbols. They're going to give us lighting symbols, but unless there's a real mistake on in the lighting plan in that set, you don't really need these because there's going to be a whole new set in there'll be a lighting schedule. So I don't really use this general set, and now I will for the switches. If there's some that kind of look funky, the ones that I don't already recognize, then I'll look here for that. Okay, and then all the dimmers, because they could be anything. Okay, so you want to make sure you have a good working knowledge of all of your symbols for electrical, because there are so many, and each electrical engineer could be so different in the way that they represent stuff. And now there are a lot of outlets that include GFCI, so you want to make sure you don't forget that. Sorry, it's a lot of talking. You want to note that if that is there. And then you can imagine all of the outlets. If there's a kitchen, there are going to be quite a few different types of outlets. So you want to really make it sure you point these 50 amp, the 30 amp, the 15 amp, because that's very important. And that's why I tend to do the electrical plan, the power plan first, because of this kind of thing. And if you don't get on the harder stuff first in an electrical plan, so much different stuff. And then by the time you've counted everything, then you have to go back and do all the conduit runs, which it should be a day to come up with a better way to think about doing your conduit runs, especially when you have units. So it doesn't make a difference if it's a hotel, if it's apartment complexes. When you have units that are exactly the same, you can always, when it comes to the power runs, as you can imagine in your mind, because a good estimator is supposed to imagine in their mind the outcome of this project. If you have different units, and it's so worth it, So if you think you like this so far, make sure you like it, as for a couple of reasons. It helps other people like know that I'm here, and it does help me to support all of the other things avenues that we're trying to make people smart. So if you're good so far, and leave a comment, because we've done a lot of research on what people want to see as far as the estimating, and construction estimating is one of the topics. And I get a lot of electrical estimating, and so yeah, that's easy, right? But construction estimating can be anything, right? It could be framing, drywall, flooring, concrete, roofing, underground utilities, landscape, final cleaning. So help us out a little bit, and leave us a comment here on if it's other than electrical. Let us know, and we'd be happy to do a full series for you here and some on Patreon, so you can support other people and support the nonprofit that we have that helps kids learn this stuff for free. See, kids deserve free stuff. All right, so all of our symbols, make sure, and you'll have to, that you are noting the symbols for the communication systems, and rule of thumb, rule of thumb, rule of thumb. Always when you have fire components, any kind of ceiling mounted anything, cameras, speakers, any any piece of equipment in the communication, data communication, telecommunications, and I always give it a 4-inch junction box and conduit to the ceiling, because typically that's what they need to for TV outlet. The outlet itself, the outlet is what the TV provider gives, but the electrician provides the box that goes into the wall and the conduit that goes to their main system. So it's up to us as the high voltage electrician to provide always the junction boxes for these symbols, and it's usually noted, but like on the fire plan, it's not going to show you a junction box. It'll just show you the fire component. So I always give them a junction box and 3/4 inch conduit to the ceiling, which I usually just give them 6 or 10 feet depending on the ceiling. Okay, and so you want to be familiar with all of your symbols. Okay, so this is the cover sheet, and this is everything that's in this. Remember, we're talking about a hotel, right? And so the usual layout for a hotel is general notes, what we're looking at right now, and then the site plan. So all of the outside power and poles, and who knows, nowadays they may have EV charging stations, that kind of stuff. So it really depends. So we're going to take a look at that. Oh, and then there's a pool. So we have the pool area, and when we talk about all of that, it's where's the main distribution for the hotel. Somewhere in the back of the hotel, I'm sure, probably enclosed in something. And so when you think about the pool area, it's going to have its own panel. But again, the main power is going to come from the main distribution panel, where all the power for all the rooms are going to come from that main block of distribution, wherever it is. And so the most challenging part, and we'll see when we get to the single line diagram, is to physically look at the plans and try to figure out, okay, where's the panel for the pool, where's the panel, main distribution panel that it draws off of, and just make sure you physically take that measurement, because power feeders are very expensive, and so you never want to be short. Alright, so we have site plan, pool plan, and now we get into the first floor, power and signal, data, phone. That's what that is. And then we have 4 floors. Now, in terms of hotels, I've seen it a million times, but you really have to make sure before you take the shortcut. Usually the first floor, and see, this is such a big hotel, they've broken up the first floor into separate parts. So usually the first floor is all administrative, right? There's never any rooms on a first floor of a hotel. Second floor, there may be some rooms, but it may be administrative. It all depends. But once you get to 3, 4, 5, they're usually cookie cutter floors, where we have all the rooms, and the room types may be all in the same place. 4 may not be. And that'll be helpful if it is when we talk about the power feeders. If 3 or 4 of the floors are exactly the same, then we can say one set of our power feeder runs times 3, because it's all the same, so we hope for that. I don't remember, so we're going to go in it together on this one. So yeah, I lost my train of thought. So power and signal, all of those. So yeah, if all of the rooms, I got it, are all the same, then we can do that multiplication. So first floor is usually its own, so you got to do that all by itself. Second floor, third floor may be the same, where we have all the rooms, and then in the center of the floor we have all of the power components, all of the panels for the rooms, and then we have the laundry and that kind of stuff, either back at one end or in that same area. So we're going to check this out. Lighting plan works the same way. And then that single line diagram is where we're gonna really have to sit back and think and make sure we know the physical locations of all of the panels so we can accurately run all of the power feeders. So that's that. And so how do we approach? I always approach the power plans first just to get them out of the way because they're a pain. I never do the runs of any of the branch circuitry or the home runs until the very last thing, because that enables me to look over my work 3-4 times, 2 or 3 times at least, to see if I've missed any counts. So that's good. So I would always start with the hardest stuff, get the electrical over with, and then once you do that, then the easy stuff is like, okay, let me go ahead and count all of the breakers in all of these panels that I'm going to need. And I would start building the estimate even before we're finished doing the takeoff, because you can do that depending if you do it that way. Very last thing are all of the wire runs and then doing the multiplication for the wire, right? 2 number 8s, 1 number 10 times 300 feet, or 5,000 feet of number 12 and 3/4 inch conduit. So I always leave that for last because I want my brain to be fresh after doing all this other stuff, and two, I give myself 3 days, no matter if it's this kind of estimate or any other electrical estimate, at least 3 days. 1 day for the takeoff, another day for checking the takeoff and getting it on the Excel spreadsheet, and then the last day for checking those wire runs, making sure they're accurate and getting them on the Excel spreadsheet. Okay, so those are the sheets we're going to be looking at, all of our symbols, everything. And what do we have next? Okay, so this is our site plan. You see how this is just crazy. Okay, a lot of bubbles. So a lot of things have changed. Okay, GFCI, waterproof, going to what? Panel, house 1, probably position 57. And chances are a lot of these on the perimeter probably are. Maybe not. 57, that one is 60. Okay. And then, yeah, it's just a matter of, now, let's look at some symbols and what the symbols are trying to tell us. So, what did the bubbles tell us? They've changed some of the design from the original set of plans. And so instead of redoing the full set, they've given these revision clouds and given these mark number 1, and on the note somewhere it should tell us, well, there's number 2, somewhere is number 1. I don't know. They've hidden number 1. They've only given me 2 number 2s. Okay, it's somewhere. Okay, but we won't look for it right now because it should be here just like number 2 is. Okay, we'll figure it out. Okay, but we don't really care, right? We don't really care, because we're just going to count that as a waterproof GFCI. We'll find the number 1 on some other page somewhere. Okay, so what we would do at this point, what are we looking at? That's all of our poles, our lights, the F17s, and then we have whatever 18 is. So let's look at our keynotes in their sheet notes. So of course on every page you're going to have general notes that you need to review and take notes. That's why the electrical set, it's not so much that it's hard to do an estimate, it's just time consuming, especially when it's something like this. And so, yeah, when we look at the pricing, we'll see, yeah, we have the various versions of the copper wire, so it's telling us which one to use. And so we'll go over the cost book on, and we hope you'll join us on Patreon. The differences, and then what we mean with the differences, copper And, it's good to know all the technical aspects of what you do. Okay, and so we'll go over that. Electrical contractor to supply owner with drawings of the as-built condition. The electrical contractor shall comply with all local, state, and county federal codes. All lighting circuits shall be the responsibility of the electrical contractor. If any discrepancies, lighting fixtures, quantity shall be field verified prior to bid. I don't know what that means, because they never let you do that. So bid verified or field verified prior to bid, they never let you do that. So unless they have a walkthrough bid, but this is from the ground up, so I don't know what that can mean. All right, and all the outlets, 30 amps or less, communication system, no more than 48 inches, measured from the top. Okay, those are really notes for the installation for the electrician. What to do with firewalls, all junction boxes. It looks like fireproof. That's interesting. Okay, disconnection for all mechanical equipment. That's all standard stuff. Okay, so look at the plan. So we have all of the power poles that we have to count, and of course they don't show you the conduit. You just know that they're connected based on, or how they're connected based on the subscript on the panel that they're going to. So you just directly connect them. Usually number 10 wire, 3/4 inch PVC. Everything underground is going to be PVC. So what do you do when you're not really given a road to toe when it comes to how to run the wire? Well, you got to do it in a more logical way. So you just assume, unless you're extremely special, right? You're not going to go, ooh, you're not going to do that. You're going to go all the way across. And you have to assume in your mind that there's trenching. And I always like to think, okay, I'm going to look at and this is kind of a good way to think about it too, if you really want to get into it and think about the best way to run your conduit, because it's really based on our underground utility plan, right, from our civil set. How are they running all of the other underground utilities, because it would probably go within that same kind of pathway. And so I look at that first and say, okay, well, there's a lot of stuff on the exterior. You're not going to be off, because they have to be connected. So are they connected? That doesn't even make sense. We would run the wire here and then bring it down and connect it, and it's all about, okay, well, how was it trenched? So you want to kind of bring that into consideration too, or just do how you discuss it with the electrician. This is how I ran the underground conduit, because it kind of makes sense. Because again, you're not trying to give 100%. It's this much. You're trying to give an accurate representation. So if you were to do it that way, you're always going to add 10%. So if you do it in a logical way, you're never going to be off enough to say, oh man, I was so short. Or too much can happen. Right? Because you're going to naturally, these are going to flow together. You're not going to do each one separately. That's why they give you the subscripts and the panel number and the panel name and the subscript on the panel to let you know how they're run. So again, electrical estimating is an art and a science. So that's why it's kind of pretty tough, but you do enough of them, you'll get it. And you do the hard ones, the easy ones will be like, oh, that's easy, that'll take me an hour. Excuse me. All right, so what are we looking at? So this is the building, right? This is the building, and we can tell that all of our panels are pretty much located here inside the building, and so that gives us an idea. And then here's our pool area, and it's got a detail call out, right? It's got a call out, so it's calling me out to image number 1 on E1.2 to give me all of that pool construction. That it did that there, and it looks like it's doing it here, and we have a generator. And so always when something is from the ground up and you're the electrician, you definitely have to read the specifications, because you do have to provide temporary power, all that kind of stuff, and that's not on here. Okay, so you have to figure out how that is done, and the way you learn that is by reading the specifications. So a lot of contractors with excellent expertise are afraid to do projects like this because of stuff like that. They don't really know how it looks so big. Well, it is, but it's no bigger than a couple of homes you'd have to put together. And because you don't know how to break it down. Oh, what are we doing? What did I do? I'm bringing all kind of stuff up. Because you don't know how to break it down, you think you can't do it. So that's not necessarily true. All right, so that is let's look at some of our symbols. We've made some changes on our lights, so that's what they're trying to tell you right here. Okay, and we're going to do the full takeoff, right? The full takeoff is going to be done on Patreon, and we'll put it all together. And the whole point, everybody can count, right? So you just need a counting tool. So the best thing, and one thing we've always used, and what's represented here, is Plan Swift. We don't really use it as an estimating tool itself, like the final estimate, which you could, because you can program Plan Swift, right? You can program all the material cost and your labor rate just the same way that I personally use Craftsman Cost Book. It's like we both took a little piece of Craftsman Cost Book's equation, the way they produce there, because they do the same thing. You can program pretty much all of these to do the same thing, where Craftsman doesn't do the measurements for you, where Plan Swift does, and then you take information from Craftsman Cost Book, put it into Plan Swift, and you can shoot out because once you do all your estimates, it's on this kind of is empty now because we haven't done any takeoffs, but it gives you a list of your takeoffs. And here on the right, see, if we're doing the electrical, we can program all of these fields. They give you a few. Electrical price per square foot, that's easy. And that would shoot out an estimate for us, 3/4 inch. So they have a few things that are already programmed in here, but you can add just about everything that we do the takeoff for. So I might do one of those because I've never done it. For me, Plan Swift is just a ruler, right? I just use it as a ruler because we do everything here. So it would probably make a lot of sense to do it just for now for teaching purposes, and I think we may do that for this year, and try to do something a little different as we use Plan Swift, because for me it's the easiest thing that I've found. Makes it easy mouse. Hey, when you can tell really quick when your plans are not to scale, and easy. But for us, it's always just been a ruler. So a ruler is a ruler. All right, so this is our building, right? And so when we get into our building, we're going to get into the lighting plan, we're going to get into the power plan, but for each floor, see if they're different, and see if we can cheat a little bit. Okay, and so this is everything outside. See, once we come inside, right, this little squiggly right here says, well, there's more there's more to this, but we're going to stop it right here, because once we get inside the building in the electrical set for the building, then I was right, we do have electrical, the vehicle EV charging stations, one or two, which is pretty much going to be the future. So we need a lot of those. All right, so underground, all of the power. We got some cameras. Got some cameras on the poles too. I don't know what that's what that is. A couple of things. So we'll do all those takeoffs, and main thing we'll come back with the conduit and wire runs for that. Okay, so let's go on to the next page and start to break down each of the floors on the inside and how we would logically need to be thinking about that before we do the takeoff. All right, so now let's get to some of the other floors, and we'll get all through the Title 24 stuff. All right, so power and signal for our first floor. See, this is crazy. So yeah, always look for your first floor power plan to be nuts. All right, let me just say that. Look for it to be nuts. And so how do you think about it when it's nuts? Well, of course, you're just going to do all your counts. Okay, so that's not going to change. You know, you're going to look for all of your different types of, some are GFCI, some are not. Now, what you're going to look for too, if there is a kitchen, like here we go. Okay, so this is the equipment, and I'm not so much thinking, I'm thinking kitchen equipment, because those outlets are different. And so you want to be looking out for those, because depending on how they format the plans, the kitchen outlets are, you know, some weird NEMA numbers. NEMA whatever. But some weird NEMA, I can't even think, you know, there's so many different kinds. But they may not give you that specific NEMA whatever on in the photo, in the physical, in the picture version. But they'll tell you what piece of equipment it is connected to. And so that becomes very difficult, because, you know, as an estimator, you have to make sure you're counting, especially with electrical power, right? You want to make sure you're counting just the general purpose outlets. You know, you have the accurate count on that, as opposed to the GFCI ones that are waterproof and all the way down the line, and especially the NEMA 30, the NEMA 5s, whatever. You want to be accurate. And so when you have a kitchen, just be aware of your kitchen schedule, and try to correlate that schedule with the outlets you see in the kitchen, and don't double up on your counts, because you can very easily. I have one like that. Here's some other recordings we made to clear that up, but yes, that does happen. So this is all of our, so this is kitchen equipment too. Okay, and it gives you, okay, the wire sizes, that's good. NEMA receptacle, but okay, by owner NEMA, but what kind? Okay, see, this is very helpful. So you can run your your wire. As we know, for electrical, most things are 12, right? But not everything. And so here we have a number 3 and a number 8 for our iron mite. Oh, no. For the Insta hot water heater. Okay, that's 1 1/4 inch conduit, number 8, number 3. 2 number 3s, 1 number 8, and 1 1/4 inch conduit. So, and then we have something that's a number 10. So you want to look through that, because typically everything is number 12, so you don't have to pull out your number 12s unless it's 4 number 12s instead of just 3. Like I just saw that. This one right here, this one right here, the train something. Coil fan coil unit. That one is 3 number 12s and 1 number 12 ground. So that's why we do the electrical set first, because you have to be aware of this stuff, and it is very important now. NEMA type, it must come with the equipment if I don't need to worry about what kind it is, because I need to know what kind it is. So we won't worry about that now. All right. So we look for the kitchen, right? Because, oh, look, we have quantity of outlets. I just saw that. So, oh, it's not going to be very helpful. So when we have them here, but we also have them on the plan, it's like, oh, that's good. You got to think about how you're going to count that, because you could easily double count. So this is the kitchen equipment and the mechanical equipment schedule only, not just the regular offices. But look, these have some funky outlets themselves, so we got to make sure we know the difference. For thermostats, junction box for the thermostats, they're telling us that that's good. The manager controls the heat, you guys. That's right though, right? All right. Okay, so it's just a counting situation. Now when we do the wire, that's going to be different, right? Because then we have to pay attention to what position on the panel each of these are connected to in order for us to use our brains to run our conduit. So make sure you follow that part in the next couple days. We're going to be working on this this week and knock out the electrical first as soon as possible. That's why we're taking this long overview of the sheets in general, because the next videos will be the actual takeoffs, problems we found, and then those conduit and wire runs, which are the most important part. All right, so this is our first floor. No rooms here, right? So first floor you're going to have to do a lot of, and here's the scale. So now we've come inside the building, so pretty much all the panels and stuff are here. The engineer's room. Okay. And this is I have to see what that is. Yeah, right, that's the main distribution out here, this whole little thing right here, and then all of our new panels here, and then there's one here, and that's the house. There's the EV panel, but the pool panel must be in the pool. Oh wait, yeah, it must be in the pool room itself. All right, so second floor. Okay, wait. First floor, part 2. Sorry. Whoop, that's right. It's huge. So we break it off right here. Okay, so we count everything here on this side, and then we go to the next page, still first floor, and then we connect it here and keep moving it. Okay, and so that's a lot. That's a lot of counting. You count till your eyeballs fall out on this one, but it's easy. The other part, when we come back, is how do we do the wire? Pretty much when you see these special receptacles, those are always home run. But see, this is something I need to make sure. Oh, these are the P-Tech. Okay. And see, I'm going to look on that equipment schedule, make sure I know the wire configuration, because mechanical equipment may or may not be number 12. So you do have to confirm so you're not off on your wire, because it's very expensive. That copper wire is very expensive, and you want to make sure you are doing the right thing. Okay, and so again, we know how the outlets are connected based on what position on the panel they're going to. And they said this right here was typical. They put a circle around and said it was typical and gave it a keynote. So I got to go back and see what that is, because it's the TV outlet and some other outlet together. And so for this one, we're going to need a junction box, I'm almost certain, for the TV outlet. So, and those are kind of things you don't see, but you know, because That's just the way it has to be. You need a junction box for these outlets, but that these general purpose and GFCIs and all of that are part of the high voltage electrician scope of work. So we don't question that we need a junction box for that. You see, we kind of know because the outlet goes inside the junction box, but the outlet is the high voltage electrician scope of work, so we don't question that junction box. It's just the one for the low voltage electrician scope of work that we have to provide the junction box. A duplex one when we have data and phone, so it has to accommodate two outlets, or just a single one when it's the thermostat, but it has to be big enough. So they have to coordinate. The electrician is the one trade that comes for the foundations even poured, right? Temporary power all the way through the new lights being put in the bathroom, new TV outlets, beginning to end. All right, so that's the first floor. So there are no. Are there rooms? Are those rooms? Yes, there are rooms. Okay. There are no rooms on this end. There are. Oh, okay. What is this? A home suites? I've never been to one. Oh, yes, I have, but I've never been stayed on the first floor. I never stay on the first floor of anything. Okay, so this is the hard part because they're giving me. See, in this, I don't know if I talked about this here before. Okay, because they're showing me guest room, whatever. It's not telling me what kind. So if I thought this was like a queen two or whatever, then I would do this one, and every time I see a queen two, I would just ignore all this other stuff, right? Because it's the same. But I don't know that I could do that with this one. So that's something to think about. It's like there may not be any shortcuts on this one. Alright, so yeah, this is the first floor, and we got rooms just called guest room. Are they all the same? We have to look into that. If they're all the same, that's even better, but I don't think so. If they're all the same, that's even better. We'll look into that, because really, if that's the case, in terms of counting all the outlets and stuff, only thing we'd have to do is figure out where the panel is. See, 2C. It's not going to be a fun ride. It'll be fun in terms of teaching it, but it's going to be a crazy ride, let me tell you. Because panel 2A, 2 da 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 da, okay. 2C, powers up. All of these. And these will get powered by 2A. It's not going to be an easy ride. Life isn't easy. Alright, so that's the second floor, part 1. Second floor, part 1. First floor, part 2. Okay. Yeah, it's still bad. It still doesn't make a difference because first floor has rooms on it. Second floor, part 1, they're not broken down. They're just all the same. We'll look to see if they're the same. But the whole point is trying to see if you could save yourself some time doing one in the math, but you can't unless they're absolutely all the same rooms. But at this point, they're kind of looking like they're all the same. Except for is at the end, and then that one at the end. Yeah, because you want to save yourself some time. You don't want to do all this counting. All right, but yes, so in terms of the hardest thing about this is where's the panel? Okay, so when the room is broken up in two, part two, you got to kind of orient yourself as to where the panel is when you go to part one, because where we breaking up the room, the floor is right here. So all of the ones we're about to look at are over here, farther away, not closer. So panels like right here. And so now you have to figure out which of these go exactly where. Yeah, that's not going to be fun, but it'd be very educational. All right, third floor, part one. Let's see, that look different. Yeah, it is, because the third floor has this. That's something totally different. So yeah, boys and girls, it looks like this is a project that you're just got to count. And what we can do is any of the home runs, they have to be methodical, because all of the panels for everywhere, everything everywhere is all right here. And so you got to think, okay, how can I best run all of the home runs? So within the room it's easy, right? Within the room you're just running this. Okay, so you got to go, that's different. So how many home runs? Think about how many home runs in a room. Well, and what do I mean? How many home runs have to go over to this area right here? And so 3C-36, right? All that runs together. So that's one home run. 3C-38, that's two home runs. That's everything here. And then all these special receptacles, they're all their own home run. So then you just got to break down, okay, there's a 44, 38, I saw another 38. So these are connected. And then home run to, okay, so that's how you got to think about that. That's great. Woo! All right. But we can do it. All right, fourth floor, more craziness. Third floor, more crazy. Fourth floor, crazy. Crazy, more crazy. Now we have the roof plan. Now what do we do with the roof? The roof has the mechanical equipment on it. So, unfortunately, we need to name each thing individually, each of the mechanical equipment power run separately. Get a good idea where the panels are for that. So they're at H2. So wherever panel H2, so we got to go back to where? The initial power plan, kind of physically find out where it is. If we had to imagine it down in the building somewhere in here, right? Oh, good, look. It tells us. That's beautiful. We don't have to guess. That's the best thing they could do for you for the roof equipment. Okay, so now you gotta figure out all the disconnects for the mechanical equipment, and then just get to running or determine ahead of time if all of these are the same wire configuration, because we got the schedule, right? We got the equipment schedule that had all of the wire configurations for all of this, meaning what size wire and conduit to run to the panel. All of that was given to us on that schedule. So what I normally do is just truck it out, EF1, get my measuring, Measure it from like right here, boom, boom. That's that, plus 10 feet. Always give it at least 10 feet down, because I'm assuming it's inside, right? It's not on top of the roof. But our single line diagram is going to tell us exactly where each of the panels are. Okay, so we made it to the roof, power roof. Oh good, look, here we go. All the disconnects, so it just doesn't tell us anything. Oh yes it does, there we go. So yeah, the only thing we have to really look out for, we got two number 12s, two number 8s, one number 10. Those two, these three, and then those two down there. Everything else is our typical home run 3 number 12s and whatever 3/4 inch conduit. So it's just a few things we have to pull out. Everything else we don't have to mark it separately, because it's all number 12 wire. And of course we're going to read all of the notes in general. We're going to verify, coordinate with the architect and the equipment vendor the exact location of the equipment, including final connection requirements. Coordinate the location of the disconnect switch with da 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 da. And let's go to the next page. Alright. So we are now at the lighting plan. Very easy. Okay, so we just got to count the lights. And what's this telling us? Let's see what notation that is giving us. It should tell us the first thing here is the mark of the light, and this is probably the lighting control it's connected to. That's what that looks like. Let's see. Let's see. Yeah. Let's keep going and see what we got. A lot of floors. And see, the good thing about these, now these you can, I believe you can cheat. I mean, you probably could cheat with the other one, but you gotta know how to do it, because it looks like that's the 4th floor. I just pan it out. Let's see. That's the 3rd floor. 4th floor. Something look different. No, back here look different. Oh yeah, where they're connected to. So I think you do this floor and just multiply by 2. At least you can get away with that. Let's see. Oh, where? Let's see. Yeah, the panels. Yeah, the only thing changes here is, yeah, I think you can do that. Now, what was? We're at the single line diagram. I'm not quite sure what that, what those notations were, but I think that's what they were. Let's go back. We first get there. Yeah, zone. Yeah. Yeah, I believe that's the lighting control it's connected to. And you can imagine this is just full of, yeah, because that's the mark for the light. Just want to make sure you're reading the right stuff. That's the mark. Oh, okay, I get it. 2B, 29B, yeah, 2B, that is probably the panel, yeah, probably, I don't know, but these are the kind where they give you the light. They don't even tell you the light on the plan. They don't give you the light on the plan. They only tell you here, and then you have to figure it out for yourself. Okay, so this one is L1.
sucks, because it's going to require you to really not make mistakes when they should have given you all the marks instead of this other crap that they gave you. Yeah. They just unnecessarily made this one hard. That's unnecessary. Sad. Alright, but we'll get it done. Alright. Single line diagram. So we have 4 floors. Alright, so not helpful at all. See, this is all the new stuff that had to be added or changed. Okay, so the main distribution panel is here. We saw that is on the first floor. And then all of the grounding requirements. And then all of the main panels. Okay, and EV control, and then we should have our generator. Yeah, that was new. That was added. All the generator and what's needed for the generator. Okay, and then all of these. Now, we just have to look for panel DP2, and those are probably on each of the floors and connected to each of the panels on each of the floors, so that makes sense. And so what we have to physically say, run all of those home runs, each room. Here are the panels, and then the main distribution panel, we're looking at a run from there to each of those. However, we just saw that at the single line. But then we have to run each room of its, in all of the branch circuitry that are connected together. Figure out how many home runs now, and at what point are we gonna, because through these 3, let me see, 4, 3C36, this one, 3C36. So from here, 3C36, here, and here. So this one, and all of those are all connected, branched together. And then they go to, at some point, I'd probably take them from right here, boom, here, to 3C. So that's just one. And these go to 3C38, so 3C38, all these are branched together. Wherever I see 3C38, 3C38 here, it branched to here, which is branched to here, here, and here, all together, and run to 3C. Okay, so that's how we be doing that, room by room by room. Fun. Alright, and then all the panels. Alright, so I have to just go through these and determine all of the breakers we need. 400 amp 3-pole, and just panel by panel and what we need. And then I'm sure we have some all of our and then here's all the details, what the stuff should look like, basic, how we're taking the conduit through the ceiling, through the walls, through everything, and what's required, like the mechanical equipment when it has to come down through. They have to know how to make sure the penetrations through the walls are right. And so us as estimators for something like that, we just give an allowance when we know it has to, or it has to go through a sleeve or something like that to go through the wall. We give it that allowance. So from this point, you always want to do a full review of your electrical set. This is a huge project to undertake, but whether it's a 3-step process. You do your takeoffs, you do your pricing from the cost book, and you professionally show it on your Excel spreadsheet. And so that's what we're going to be doing on Patreon now. We're going to do the actual takeoffs, show some cost book information, man-hour totals, which is vital. How long does it take to do this thing? So please give us a like. Please subscribe. I always like to be able to show what I know and share with people. So please subscribe. I'd love that. That'd be great. And so you can always see what we have coming up new. And if you so choose, please join us at the Patreon site too. Have a good rest of your weekend, and I'll see you on Monday. Hey everyone, I hope you are doing well. In this video, we are going to look over this is an Arby's, and in this short section, we're going to look over the panel and the wiring, because it is very important when you are doing your wire totals. And you can see kind of this mess right here that we have, that in a kitchen, for a kitchen, which an Arby's is a kitchen, it's important to understand that you have a lot of different equipment that's gonna require a lot of different wire sizes. And so this one is kind of tricky, but a kitchen is always tricky. And so I want to point out some things to look for when you are trying to figure out the correct wire, the wire totals, the configurations for the wire. Make sure you have, all the number 10s correct, number 10s, number 8s, and number 12s. Because if you're doing an estimate, either, for a firm, the electrician can immediately tell what different size wire that you need. And so you need to be able to quickly go to that information, and then from the panel to the power plan, to be able to determine what you need, and then go back to the plan to determine the actual lengths of everything. And so this should be pretty exciting if you are into or trying to get a really good grasp on electrical estimating, and more so the different types of buildings. You need to be thinking along different routes. And when you are dealing with kitchens, especially buildings that are exclusively kitchens, these are the kind of things that you need to think about. The equipment schedule. Okay, so if this is what you like and this is what you want to learn about, make sure to subscribe and to like, so other people like you can find out more. And I'm also going to try to do now timestamps, so you can go right to what you want, and we can get it going. So, all right, now if I can find the time. Okay, so we're talking about 2:30. We're going to get started. So let me take my mug off, and let's get going. All right, so this is 2:37 actually. All right, so we are going to get started on looking at the panels. I'm going to look at this whole project, video, the whole project for you. And if you are a Patreon subscriber, we're going to have every piece and an ounce of this, from the lighting plan all the way down. So, join us there. It's economical. And really, I don't really think there's anybody that can teach you in such great detail as I can. Different types of projects from personal experience, not just, general knowledge. And I definitely give you all of my personal experience. You can ask me questions over there. So make sure to subscribe. All right. So the topic of this video is one of the last steps that we perform is I do, because you have to have a fresh mind. You can't be tired, okay, when you're doing your wire runs and trying to figure out, what pieces of equipment. And look, I already dropped my paper. What pieces of equipment go for what, okay, when it comes to your kitchen. You want to be accurate. And I've had great success with winning for my clients because, I get in there and detail is my thing. Everybody's not created to do this, but somehow I figured out I am. And, I try to teach that. So every project is going to be different. You want to do, even if you don't have a real good reason, you want to go ahead and do the estimates if you have access to plans. I'm going to start packaging up all of my different types of plans. So I'll have a package for schools, for kitchens, for apartments, for hotels. So you can see, because in each type of building, you're going to have a different mindset on how to do that takeoff. Okay. So when we have a kitchen, we know we have equipment. We know that equipment is going to be require different amperage, power, or however you want to think about it, requirements. And so we always want to think. Most of our, we run on 120, 208, 120, 208, alternating current, right? And so everything that comes into the building is 120, 208, 120, 208, but we have to power everything from the rooftop unit to our cell phones, right? And so everything is going to require a different a power requirement, and the only way we can provide that to each of the pieces of equipment is through the wire, the adapter. That's what the adapter is. It's converting the 12208, 12208 through the wiring that we provide from the outlet or through the little box we plug in, and we plug our cable, and then we connect it to our phone. That adapter, or that plug where you plug it in, or if it's hardwired, that wire is doing the job of converting our 12208, 12208 into whatever our cell phone needs in terms of amperage and power, what our rooftop unit needs in terms of amperage and power. Okay, so you have to think about, when you're doing an electrical estimate, everything in that way. Now, you can also rest assured that in commercial construction, the majority of the building wire is a number 12. If it's not a number 12, the general purpose wiring for a building is usually number 12. So most of your home runs are number 12. But if they're not, you'll immediately know by a few things. When you're looking on your panel, you'll know it's probably not just two number 12s and one number 12 ground, right? Because we have hot, neutral, hot, cold, and neutral, right? So we have three. It could be up to a 3-pole, whatever. And so we know, chances are, if the breaker is more than one pole, this is a 20 amp 1-pole breaker, chances are the home run for that circuit is probably a number 12. It's questionable when we have 2-pole, 3-pole breakers. Chances are it's not two number 12, one number 12 ground. Chances are it's maybe three number 12s and one number 12 ground, or something totally different. Number 8s, number 10s, number whatever. Okay, and so the best way, if they do really depends on the electrical engineer, how they present their panels. But I wanted to display this one because this one was very good in terms of telling me what pieces of equipment need what wire. And it was good. It's good. It's perfect, because now I can go from the panel. So I always have to count my breakers. That's part of our takeoff for our electrical. We have to count the breakers in the panel. And so the typical ones usually are going to be circuited by a number 12. Two number 12, one number 12 ground is usually the 21, or lighting is usually number 10. But then you got to, it all depends. But in terms of our job here is we are trying to make sure we have all of the wire required based on the plans. And so the best way to know how everything is wired in this case with this set of plans, it tells us on our panel. So here's I think our single line is on another page. Where is it? Okay, so here's our single line diagram. So we have panel A, which is the main distribution panel, and then it feeds off to the other panels. Okay, so that's our main single line. It's showing us all the power that's coming to the building in this case, because I believe this is from the ground up. Yep. And so it's showing us from the transformer all the way into the building, and then all the panels that are operating or running all the power in the building. And so our utility transformer, and this tells us that our power feeders are underground, and then this is the notation that tells us, so U400-A4, so I'm going to have to provide two sets of 4 number 30 in a 2-inch conduit. I know it's underground, and so I'm going to have a small portion for the transition, maybe rigid steel once it comes up. Okay, so I need this distance. So what do I have to do? I have to go to the site plan and physically measure the distance from the utility transformer. I think that might be the only thing I haven't done, to the CT cabinet. Okay, but where is the CT cabinet? Well, we got to go another step, right? We have to go to our site plan. Okay, so let's go to the site plan, because we need to be able to measure the distance between the transformer and the CT cabinet, and then from the CT cabinet to the main distribution panel, we have to determine these actual lengths. And from the main distribution panel A to each of the panels. And I think I have that messed up too. So let's go to the site plan first and determine how we do that. All right, so here's the site plan. And now here it says proposed transformer location. Well, it also says, when I went in the reading, it may not be there, verify. Well, this is all we have. And so this is what we're going to go by. Okay, as far as that length from the transformer to the main distribution. Okay, so here's the building. We know the main distribution panel is somewhere on the building. So it'd be nice if they told us, they have this there, but, without noting it, that could be anything. But that's actually the pretty good, accurate location of the main distribution. But how did I know that? Okay, so I have to go, well, what I did is, okay, here's the building, and here's the drive-through. Okay, so it gives me kind of a point of reference when I look at the actual power plan. Here's the building, and here's the drive-through. And so the power plan is going to tell me where the panels are. And so the panels are here. Okay, so I can go back to the site plan. Where are the panels? Here's the drive-through, and from my power plan, I noted they were basically at the end of that same wall. So they're approximately right here. Okay, so now I can do all of my measurements. I can determine. Now, you probably, if you really want to get good with it, but I'm going to give a video to my electrician and say, okay, this is how I ran the secondary. Okay. And so what I'll probably do, since I know it's here, now you got to think this is from the ground up. So what are they going to do? They're going to do all the trenching for all of the lines that need to be run long before this building ever gets here, long before the concrete gets there. And so what they'll probably do is, typically, they're not going to run lines all over the place. With logically, sorry to say, 90% males, they just may run spaghetti all over, but it would be more logical to, if we're going to run, if this is actually where these two poles are going to go, then we probably are going to run this somewhere in here. So I'm not trenching all over the place. Run it here to here and then to here. So that's probably how I would run my secondary, or just from here to here. It wouldn't really make a difference for this purpose, because this isn't set in stone. This is giving them an approximation. And trust me, if we're doing it this way with a digitized software, very precise like this, we're doing it 10 times better and more accurately than anybody that is not doing it this way. That's why this is the only way I teach. I'm not going to teach you any way that you're not going to be number 1, 2, or 3 on the GC's list to be chosen. That's for sure. Okay, so this is how it gets done. All right, so we can determine this length. I need to know that anyway. It's already scaled, so I'm just going to call this the secondary. And then I'm just going to say we're going to go from it to here and then here. Okay, so that's about 178 linear feet. Okay, so that takes care of that. So we know the main distribution panel is here and all of everything is there. So, I could just do an approximation at this point. If I know actually the meter was out here, but panel A is like right here, B and C. And so I'm going to go like, okay, that's 5 feet. And because it's going through the wall, so I give that 10 feet, 10 feet, 10 feet. So I give it 10 feet where A is from that. And then they're right next to each other. So I give a distance of at least 10 feet apart for each of the panels. That'd be more than enough, I think. Okay, so that's how you would do that part. Okay, so remember, single line diagrams not to scale. You have to go back to wherever it's appropriate to go back to. Like in this case, the site plan to get those actual linears. Okay, now let's just go back to the original topic because that's very useful. Okay, and so that's why your electrical estimate is like a 3-4 step process in terms of your takeoff. You could sit there and try to do from the ground up, like, at one shot, but I would say don't because, it's a lot of steps and you want to be clear and you want to be accurate. You want your brain to be nice and clear and thinking right when you're doing your measurements and stuff. Okay, so that's where you really want to be clear. Okay, so go back to the topic of I need to make sure I have all of the correct wire for a kitchen or anything that has a lot of machine or mechanical equipment. You're going to definitely have way more than number 12s. Okay, and here's our panels, and this is our equipment schedule. In a kitchen, you're going to have an equipment schedule. Okay, and so what's it telling us? These are the outlets. So, and in this case, they didn't mark. I mean, some of the outlets you could tell they're specialty outlets, but it's not this many. And so now the next problem with this set of plans is like, okay, you didn't tell me on the plans which one these were, but you have outlets and whatever. So what do you have to do? What am I going to do? Some are quads, some are dupes, some are simplex. So I'm going to just give the electrician my counts of the quads and whatever. And if they say they're for some special purpose, I'll make sure I note that. But then I'm also going to give them, okay, you have this many NEMA 520s because the plan didn't really demark, right? Didn't really tell me which of those outlets are a 520. Remember, the kitchen format thinking pattern, okay? You're going to get an equipment schedule. I would say, and see, I didn't do this in this case. I did it afterwards. I'm not following my own advice because I got a zillion of these to look over. And so it's like, okay, we could do this for this much, Oh, wait. Better go ahead and add an extra hour and a half or something for this kind of stuff when the plans aren't as clear as they should be. And again, they're telling us here how the equipment is connected, either by this type of outlet or a direct connect, meaning the wire just straight going to the panel. Okay, but on the plan, okay, let's go to the plan. And this is problems with estimation. I hate when people say estimation. That's really not what we say here in America. Okay, estimation isn't for construction. Estimation is more like for math. We're estimators. It's not estimation. That's how I know it's something fishy about your company when you say estimate. I mean, it's okay, but that's not what we use for construction estimating. All right, so just wanted to say, dog it, and I forgot to try my translator. So because I'm doing this in all kind of, because I've noticed people are from all different countries, which is cool, right? I wish I spoke another language. I wish, trust me. All right, so what are we talking about? I don't know. Oh, the outlets. Okay, so these right here, that's a symbol for a specialty outlet. But you see here, they don't say what type, NEMA, da 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 da, which they should. And then let's just highlight, because I did my best to try to say, okay, this kind of outlet, that kind of outlet. So these, all the ones that little dots on the reds. See, these are outlets that didn't have a NEMA, da da da, whatever. But I know they're in the kitchen, so it's got to be one of the ones that they're talking about on the equipment schedule. And then two, you can think, okay, oh, that's another problem. But we'll talk about that problem when we talk about the power plan. But, okay, so that's the problem you're going to have. See, that's a quad. No, and I don't even know. And see, they're all mixed up. That's not, oh, see, that's not a quad. Yes, it is a quad. Those two are quads. But is it a quad? Or is it just connected at this point right here? Okay, yeah. We got to check it out. Lot of problems. Okay, so kitchen, you figure in the kitchen area, which is all of this. And then they mark this off and say, oh, everything in here is connected to panel, da 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 da. That's what this is. But then it's like nothing, there's no call out to say, okay, are there outlets in here? Or are they the outlets on the equipment schedule? But then no, because this is equipment too. All of this. So that's how this kind of plan can be very confusing. I'm probably confusing you just explaining it, right? Okay, but think kitchen plan, confusing, equipment schedule. Some plans I've have done very well, where they would put like the equipment, because all the equipment is numbered. So they would put the equipment number next to the outlet. They would put D74. And so I was like, okay, this must be a NEMA from the equipment schedule, right? D74 would be whatever, quad dupe, and NEMA 5, whatever. But this plan doesn't do that. So it kind of makes it difficult. But see, though in those cases, that's why you do a lot of explaining. And when I have the video to explain, because all this is going to be done tonight. And so either the videos for everything will be done tonight. The majority of them, the detailed estimate, looking at the man-hour totals, all that, please join Patreon. It's so worth it. And you get man-hour calculators of your own. You get the content early. You get to ask personal questions not personal questions. Construction questions that get answered. It's so worth it. And you let me know you love me. No, I'm just kidding. I'm married. I don't even know if they love me, but they know I'm smart, and you do too. All right, so let's answer the original reason why I made the video. To be able to determine accurately. Okay, so you got your equipment. So some of this equipment, some of these home runs aren't number 12s, is the whole point. And you need to be able to determine which ones are not, so you don't underestimate your stuff here. Because in commercial, the majority of everything it's number 12. But rest assured, when you see a home run, that is like this. 2-pole, going to 2 positions in the panel. That should be a clue. Hey, it's probably not number 12. Okay, so those should be a hint to you at any time you see a plan and you see the power plan and you see a lot of this stuff, yeah, because these are specialty outlets, so no, it's not number 12. Okay, but you see it's going to 2 different positions or 3 different positions in the panel. You know it's not number 12, and you have to be able to figure out what. Okay, so let's like the roof. Okay, the general purpose outlet, yeah, that's going to go to a single position in the panel. But look, that's going to 3 positions in panel A, so you know it's not number 12. 3 positions, no number 12. Maybe number 12s, but maybe 3 number 12s, so you got to check that one too. Okay. No, 3 positions, no number 12. Look, 2 positions, no, not number 12. No, not number 12. And so, okay, next step, go deeper into the rabbit hole. Okay, if it's not number 12, how do I find out where it is? Well, this is telling me that this 92, so I think this is an equipment number. This particular piece of mechanical equipment is going to what? Panel A, position 14 and 16. And so what I'm going to do, I'm going to go to panel A, B, 14 and 16. Look at that. That's the dry ice condensing unit. And look at that. Not number 12, number 10. Okay, so go the other way. You can go either way. Look for those home runs that have more than just one spot and say, okay, let me go to that panel at those positions and see what the wire is. Or go to the panel and say, okay, I have number 12. Okay, that's normal home run, normal home run, number 12 wire, normal. Okay, that one's okay. Next one, number 8 wire, not normal. Number 8 for what? The exhaust fan, the production control panel, exhaust fan. No, the exhaust fan is number 8, not because the panel is going to be something totally different. Okay, so I have to go to the rooftop unit just like I did, and now I know that that is number 8, and then number 10 for site lighting, and then I know it's number 10. Okay, so that's how we make sure we do it, and we do it right. Okay, and so let's go back and let me do the little timestamp here, and let's go back and just review our review. See, we did the panels here, and by the time I finish talking, it'll be about 5 more seconds. All right. And where are we? 27:56. Okay. All right, so let's do a review. Either way you go, right? Either way you go. Let's start by going to the power plant. When you go to the power plant, you are to, we know that most of our home runs are number 12 wire. 2 number 12s, 1 number 12 ground, and a 3/4 inch conduit. That's pretty much the game plan. But we know in the kitchen it may be different, but we're going to look for the home runs that have 2 positions in a panel. Okay, if they have 2 positions in a panel, we know probably it's not number 12, and we really need to know what that is so we can properly measure the home run. Okay, and do our best to measure the physical, feet. So we can go this way. Look at the power plan, search out for home runs that are more than 1 position. There's one. Or we can go just right, which I prefer because you go right to the source. You can go right to the panels. Look at each of the panels, and anywhere you see it's other than a number 12 wire, because that's what you're really looking for. What of the power components are requiring more than 2 number 12s and 1 number 12 ground? And then you just go here and you find them. And so once I find them now, I've got to go and find, either it's going to be in words, a walk-in evaporator, but more likely I'm going to have to go and look for a home run that is uh 1517 to cover those two positions, walk-in freezer. And so I'm going to go back to the power plan, and I know walk-in freezer. So I know that that junction box is connecting to the internal wiring that this freezer has already, and I'm just connecting the power through the junction box. And so now I know that physical distance, right, for that number, whatever wire, from here to, and it's going to that panel. And see, that's the complexity when you are doing anything more than like a warehouse, or office buildings are usually very easy. They only have general purpose outlets and phone jacks and computer jacks, so but when you're talking about a building that has a lot of different equipment, it's going to require a lot of different variations in the power requirement for that equipment. And now we know the only way to vary that 12208, 12208, the standard that comes into every building, whether it's commercial or for a home, we got to change the wire in order to change what the equipment receives. So please give us a like, join Patreon so we can go over together all of now the detailed pricing for this we'll go over, and the man hours. You also get man hour calculators of your own when you join either at our website or at Patreon. But thank you very much, and I will see you very soon. Hey everybody, this is Stacy, and I just wanted to point out, when you are doing your electrical estimate, you need to make sure that you are determining the difference between general purpose outlets and ones that may require more than a number 12 or specialty outlets. And remember, like I always said, when your home run is only going to one position in the panel, you can kind of be rest assured that the home run is a number 12, three number 12s. But when it is going to more than one position on the panel, that may not be the case. And so you need to find a way, either looking at the panel, or there may be some notes to tell you that anytime you have a kitchen like this one, you need to be able to determine the general purpose outlets from the specialty outlets. Okay? Any questions, make sure you email me at education@sfjohnsonconsulting.com.
This conference will now be recorded.
Oh, okay, good. So I don't have to show you that. You're able to get in.
Yeah, I was able to get into the cost book. Now, what's the estimate? Is that something different?
You know it is. And I would say, go ahead and play with that.
Play with it? Okay.
Hold on. Let me see. I've lost my. I talk and do this at the same time. I just cannot. But yeah, so I would say with that one, I'm trying to move this thing and don't want to move. Come on, don't cut off. Okay, there we go. So I would say with that, play with that and see how you like it. Okay.
Okay.
Estimate.
Okay.
But yeah, for the class, it's just for the for your pricing. But yeah, like I said, you go in and use it however you like, and then But good, I'm glad you're able to get into it. So let me open.
Actually, he has that book too. Actually, and I was telling him you mentioned that it actually that would be best to go through that. So he was just like, really? I was like, yeah. I was like, so I think the only one is he has to get an updated one because his price was a little bit off compared to what you had.
Yeah, well, I mean, a little bit, but again,
not much.
Our main thing is really to use it to help us calculate the man hours. Okay,
yeah.
So let me go back to. Okay, yeah, we're still in the cost book. So, so let's go in there real quick, and we'll go to the electric because yeah, the prices are there. Remember what the C and the S mean. But the main thing, and let's go into like right here. Okay.
Mm-hmm.
insulated die cast set screw EMT connectors. Okay, so the value of the cost book is the pricing, and remember you got to add a markup because this is assuming there's no markups, right?
Yeah.
And you know
Right.
your supplier's going to add a markup, and I always say like for the wire. Well, you see on the cost how much they say it is per 1,000 feet, but that's the cost that the supplier gets it at. Okay, so you got to remember that he's not going to give you his price. So that's why you really need to get your stuff from various suppliers because what do? Do they multiply it by 1, 2, or 3? Because they got to make something, right? They're not going to give you their price. But when you look at the cost book, that is their price. Okay, so keep that in mind. There's no markups. There's no nothing. So when I say bare bones, this is what you use to get your bare bones estimate. So, because you'll be doing the estimate, it won't hurt you to use this and just bid something for him. If he wins, and if he doesn't, then there's a process to, when you don't win, you always going to ask the GC what the winning number is. Never ask them who won because we don't share that information, whatever. But they should share with you at least what the winning number is. That way, when you bid, you'll compare it to your winning number, and you say, well, how did they do it? Or, oh, we were way too high. And then you start to try to figure out why,
Okay.
So that's really, so when you think about the cost book, you want to think about it in that way. It's not the supplier's cost. It's it's his cost. I mean, it's not the supplier's cost showing you, right, his markups and stuff. It's his cost that he has to buy it. And so you're going to go ahead, mark it up, do whatever, but just know that when you're looking at that, it's from that perspective. And more importantly, the cost book is used, remember the number after the @ sign? Okay, that's what we're going to be using on our Excel spreadsheet. And let me get one of those up real quick so you can see the comparison. And I have a plumbing one up, but that's okay. The number after the @ sign, okay? The number after the @ sign in the cost book at 0.050, that is, and keep in mind, that's the number that, what's going on here? Oh, my screen went is so crazy. That's the number that the construction industry says it takes to install one unit of, okay? And so when you look at that 0.050, and my whole emphasis is on the construction industry. Okay, not Uncle Bob, not whatever, right? The construction industry knows how long it takes you to do stuff. Okay, and so the cost book not only is good for the pricing, but it's good to tell you how long does it take to do whatever. That's our man-hour unit. So when we start to work on, when we start to work on the Excel spreadsheet, then the man-hour unit, this column, okay, that's the number that goes in there. The number that we get from the cost, because what it's doing, right, is determining how many accurate man-hours it's going to take to do each line. So this is a plumbing bid, okay? So this is a 2-inch sanitary pipe. And so what's this telling me? This is the same as conduit. You could just think it's conduit, okay? The cost is this, the total material, that's the equation. This is our labor, but that's the man-hour unit. That's the number we get from the cost book to help us accurately determine, accurately is the key, to determine how many man-hours it takes. So what this is telling me, that 0.3 is saying that for 50 linear feet of 2-inch sanitary pipe, it's going to take you at least an hour and a third of an hour to install. And so for everything in your job, right, I know you still have to work. So if you need to put me on hold, don't worry.
Oh, no. It's okay. It's my personal phone.
Okay. So each line item, if you go through and you add them up, then, you will know how many man-hours or how long it's going to take you to do your job. Okay, and so that's the value of using the cost book, is that, the cost book is going to give me the man-hour total, this number after the @ sign. And so, whatever it is,
we want to make sure we use that number at that position. But we're going to go over that again. And two, there's video on the electrical module for you to review that.
Okay.
So if,
Yep.
that's all. All right. So let's
Okay.
work on now. I'm gonna use a project that I'm actually working on, and it's a kitchen. Okay. So
Okay.
keep in mind when you have a kitchen, and this was a really good example. Okay. So let me start here. So always, you have to provide the type and the number of each type of breaker. Okay, so what do? We look at our lighting plan, our power plan, and all our breakers. We need to determine how many breakers we have, and where we get that is from our panel schedules. These are our panel schedules. So what do? We just go in and count each of the different types and kinds. And that's what I did here. Now, keep in mind, this project is an existing project. Okay, everything here is existing. So what that means is they're basically reconfiguring the existing equipment, the existing panels for the new equipment in the little, because this is a travel center where they have a KFC and a Charlie subs or Charlie something sandwiches.
Do you have the blueprint on? Because I don't see anything.
Oh, am I not sharing the screen?
No, I don't see anything. I only see where we're at on the estimating book.
Let me switch the screens. Yeah. Okay, good. So we'll be going to the end of the class. Hold on one second. Switch and okay, there we go. So I could talk about this forever and just be talking, and it's like I can't see what you're talking. All right, there we go. That's better.
There we go. A lot better.
Okay, so let's go. Let me show you the cover sheet, because I always look at the cover sheet to give me an idea. I don't know where they put this. Here we go. So this is a KFC and a Charlie's Philly Steaks inside of a travel TA, like one of those travel centers in the middle of nowhere. Okay. And so what they've done is taken the existing room or whatever, all of the existing panels. So everything there was already an existing panel. And when you have existing panels, basically what the electrician has to do now is to reconfigure each of the panels for the new equipment that's going to be connected to it. And so what I mean by reconfigure, well, some of the breakers need to be changed and replaced, right? Where some of the breakers just remain. Okay, and so in this case, when you have something like that, when you're looking at the panels, because one of your jobs is to count all of the breakers in all of the panels. So when you're looking at something that has existing, that's already existing, not from the ground up, right? You want to look within the panel schedule, because here we see existing. That lets you know that you don't need to count that breaker because it's not going to change.
Okay.
And two, it doesn't. I mean, just that's what you have to make sure. So we've got new construction where everything's new, so everything's got to be counted. And we've got renovation where if we may have a new panel and the existing panels, or in this case, every one of the existing panels is being reconfigured. Now, what that means is, yes, some of the breakers need to be changed, and then you have to, with your eagle eye, you got to say, okay, how do I know, how are they telling me which ones need to be changed and which ones existing? This was real easy because they put it there. Some places they don't. Okay. So they put it here. So I know I don't have to worry about every one of them. I don't have to count, basically, every one of them that says EX, because that means it's existing.
Okay.
And I just need to count the ones that are in new. Okay. And remember, it's either, what you have to think is how many poles. Okay, because the breaker, the amperage of the breaker is here, but how it's shown in the panel schedule tells you how many poles. Okay, and so, I mean, it tells you right here. Okay, so just know it's like,
Okay.
okay, this this one is new, but we know it's one pole because it takes up only one position, even though it
Mhm.
should tell you 20-1. Okay, that's what I'm saying.
Uh huh.
Depending on the electrician you get, it's gonna be different. Why couldn't they put the 20-1? I don't understand. If they could put the 20-30-3, why couldn't they? That's just the
Yeah.
way they, but
Okay.
that these are 20 amp one position, because remember, it's only taking up one block on this side. Where this one is taking
Okay.
up, I don't know how this is taking up. It says three, these three.
Okay.
Okay, so it's and then the shunt trip, which is a disconnect that they have connected to this fourth position, because
Uh huh.
that's kind of special. But here it tells you, and so just know when it's existing, when you're doing the panel, when you're looking at the panel, counting the breakers. Okay, are all of these new? Are some of them new? And there's got to be a way for them to tell you. Okay, if there's
Mhm.
no note, or like in this case, N and EX, you got to find out before you just start counting. Or your other alternative is just count them and assume they're all new. If they
Okay.
don't tell you, okay, if they don't tell you, and then you could let your husband know. Look, I just counted them. I can't determine if they don't say that they're new or existing, even though the panels, because the panels can be existing, but every one of the breakers gets replaced. Okay, so it's not always a case where some get replaced and some don't when it's a renovation or when it's existing panel. Okay, so keep
Uh
that
huh.
in mind. It's just okay. What really, when you're looking at a set of plans, is like, okay, what do they have here to make it clear, or how much do I have to guess? And if I have to
Mhm.
guess, I got to make a really good educated guess. Okay? And that's how you
Mhm.
do that. Just keep that in mind. Everywhere I saw it in, meaning it's new, then I know this is 1 amp because it's only taking up one position. I mean, yeah,
Mhm.
one pole. It's only taking up
Okay.
one position, but it's a 20 amp one pole, 20 amp one pole, and this tells me what it is. I don't have to guess, and I know it's new. I don't count this one
Mhm.
right, EX, 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 all the way down. Okay, so just know
Okay.
that happens. That happens when you have existing stuff being remodeled, basically. All right, so kitchen. All right, another thing to think about when you have the kitchen. Okay, when you have a kitchen, you have tons of different kitchen equipment: microwave, pressure fryer, oven, everything. So,
Mhm.
what anytime you have a connection or equipment schedule, it's going to tell you the type of what it says device, wiring device. That's the outlet.
Mhm.
Okay, so NEMA is the National Electrical Manufacturers Association, whatever. That's what NEMA is, but that's a rating of outlet. Okay, and so when you have a kitchen, they're going to give you a schedule, and they're going to tell you the different types. Here it's connected by a junction box, but the coordinate receptacle requirements with equipment provider. So, in other words, your husband is going to connect that. I don't know if I need an outlet or not, or if it's just wire, a straight wire connection from the equipment to the panel. That's what this means,
Mhm.
okay? And so this one, it says coordinate. So this tells me there is some kind of receptacle, okay, but this set of plans not telling us what it is. And so in the place of that, let's just put a junction box there.
Mhm.
Okay, this one says, okay, let me have a junction box, but it doesn't have this note. So this tells
Uh
me
huh.
maybe this warmer has just a straight, all the wire configuration from the back of the warmer is just straight wire, and we straight connecting it through the junction box to the panel. I don't know.
Okay.
Okay. When I do this count for this, I'm going to say unknown outlet for all the ones that say this, because I need to account for the material and the labor, or both. So I know
Mhm.
that I know, right, that I gotta it's gonna be some kind of outlet,
Mhm.
right? I know. So why not put in the estimate under, okay, it's unknown at this point. And then you can give it the price of a GFCI, or give it the same price as the NEMA 520 and the same
Mhm.
labor. And again, you want to account for everything, even if they don't know what it is. And then in a
Mhm.
note, you could say that all receptacles stated to be coordinated, whatever, however you want to put it. I
Mhm.
have, I've allowed it this. I've allowed it, you know, note the allowance. You know what I mean? Something like that.
Mhm. Okay.
So I actually have to do this estimate, so I'm going to show you. So when I have these, I'm going to count them, right? I'm going to count them. I'm not going,
Mhm.
if I really wanted to be anal, I could do each one separately. For equipment, C184, unknown receptacle. I could have a line item for each one of these, but I'm not, okay, because that's too much.
Okay.
What I'm going to do, I know it's some kind of special receptacle. So every time I have one
Mhm.
of these, I'm gonna do it right now. I'm gonna unknown. Did I say yeah? That's all you need to know because you know what
Yep.
you're talking about. Because it's not gonna be far after you do the takeoff that you're gonna do the estimate. So it's not like you're gonna
Mhm.
forget your thinking process. So
Okay.
for next time I see that, I'm gonna count those because yeah, I need
Uh-huh.
to count for because that may mean the outlet comes with the equipment, or it may mean that I have to provide the outlet. I don't know. They don't give me enough information, so I'm gonna count it. I'm gonna on
Mhm.
my estimate you'll see I'm going to give it a price.
Okay.
I'm gonna give it a price and a labor and say unknown see description for unknown outlet. And then at the bottom of the
Mhm.
estimate, unknown outlet are those listed. And then yeah, I'll give them listed for equipment FP P601 unknown, right? And
Mhm.
N014. So your husband knows, okay, let me look at these plans and see what she's talking about. Oh, all right. The outlet was not known, and I needed to, yeah, you needed to account for it. And so that's how we're
Okay.
going to do that. Because everything, my thing is, you don't want to add more than you have, but you don't want to neglect something where it's right in your face saying you're going to have to do it.
Mhm.
Okay, so that's how we do that. Okay, now, another thing that we got to work on. Let's look at the power plan.
Okay.
Where's the power plan? All right, so here's the little bitty power plan. Couple of problems with this power plan, but we figured them out this morning. Okay, so remember when we have a kitchen, right? You have these are the equipment tags from that same list here. So that
Mhm.
you're going to find that tag somewhere on these lists on this sheet. Okay,
Okay.
so keep in mind that's number one. So when you're counting, because your job is the estimator, right? You got to count how many outlets, how many wire, how many this and that, right? So when you're counting now from with the kitchen, you already know that if this is an equipment tag, you've already counted this from that schedule.
Oh, okay.
You see, let that sink in,
Yep.
right? Okay.
Mhm.
So you already counted, and the good thing with that schedule is if it was the same type of outlet, they repeated it more than once, right?
Okay. Mhm.
So C184 is already on that equipment schedule more than once, and it's whatever it is, okay? And a lot of times they'll note it only one time, but they'll tell you how many outlets they have of that kind, you know. So
Okay.
either
Mhm.
way, and remember, we are only talking about kitchens because
Mhm.
kitchen equipment have special outlet requirements, wire requirements, and you approach them different than if this was like an office building. Okay?
Mhm.
But they all got the same general purpose outlets. Nobody's NEMA. Only special ones are in the bathroom or near the water fountain. Okay?
Mhm.
But we talk about a kitchen. Think of all the different types pieces of equipment in your own kitchen. Well, when it
Mhm.
comes to this kind of stuff, that's high powered kitchen equipment, right? It's not something you
Mhm.
can just press, and try to use like 5 air fryers in your kitchen at once. You probably blow the breaker, because they give you one. It's like, how many people have 5 air fryers? Why do you have five? Well, yeah, you can't do that in a normal house because, yeah, them air fryers, they take up some juice. Okay,
Mhm.
but is an industrial kitchen where all the equipment, yeah, is going to be stronger and better and all that. Okay, so
Mhm.
again, go back to what's our job? To count all the wiring devices, count all the outlets. So every time you see one of these are the tags. Remember what they look like. Every time you see one of them pointed to the outlet, you already counted it. So what you're looking for are ones that don't have a tag. See now,
Mhm.
remember this is a KFC and a Charlie subs. The KFC's tags, and that's ridiculous. Heart attack one. You want heart attack one or heart attack two? The KFC tag, this shape in this type. The Charlie sub tags are these K2, K3,
Ah, okay.
okay. So we know that when we go review them, it's like, okay, how they. And again, kitchens, they're the most annoying. Like I said, kitchens, police stations, okay, annoying. Gas stations, because it's got this kind of stuff that you got to think about. You got to think about how you're going to do the takeoff before you start, okay, because you'll be messed. And you have to start over, right? There's some are NEMA this and NEMA that. Oh my God, I got to start over. Yes, I want to avoid having to start over. Okay, so let's go back to the thinking process. So equipment tag, I've already counted. And remember they said junction boxes? Okay, well that's
Mhm.
the equipment,
Yep.
the junction. But yeah, I'm going to count the junction boxes here because I didn't count the junction boxes over there. Right?
Mhm.
I didn't count any of these junction boxes over here. So yeah, I'm going to count them on
Okay.
the. So basically, I'm just looking for outlets at this point on this plan that don't have an equipment tag pointing to it because that tells me what is it? It's a general purpose outlet. It's not one of these NEMA ones, and I need to count those in addition to all the ones I've already counted. Okay, and
Mhm.
so let that sink in, right? So what you're looking for are outlets that don't have an equipment tag pointing to it. You see these three?
Mhm. Yep.
Okay, but you see that one, right? That has an equipment tag pointed to it. So
Uh
you've
huh.
already
Yep.
counted that on the other page. Okay, so that
Okay.
is the difference. So you know that these are general purpose outlets, meaning, for my charger or whatever they need it for. Okay, it's
Mhm.
not part of the equipment. And if you see here, D33, 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 well, we can just
Mhm.
daisy those together. And now we got to, there's no, unless we see another D33 somewhere on here, which we don't, which there is none, then we know
Okay.
we got to home run that to what? Position 33 in panel D. Okay, so again, kitchens. From the equipment schedule, you already counted all of the ones that is equipment. You already counted those, and so now you're looking
Mhm.
for ones that don't have it. Like these two don't have it.
Mhm.
These two, that's the Charlie's ones. That's the KFC ones. Okay, and this is where I'm gonna read six, but this is a disconnect. Okay, the wire configuration of the disconnect is telling us whatever six is, or the air handling unit. Okay, it's new. So the
Mhm.
condenser and the unit, that's the power for each one, and that tells us there's a disconnect. So when you see this box with the little thing, that's something you got to account for too. Now, mechanical equipment, meaning all your HVAC equipment, is always going to have some of it, the big stuff, right, is always going to have
Mhm.
a disconnect. So that's something you got to think about too. It's like, okay, I got to figure out where is there something telling me what the is it fused, is it non-fused, whatever. But six probably
Okay. So
tells.
that box that you showed me, that's something you have to look for what it is, or what is it?
Yeah, that's a disconnect. So remember when we were talking
Disconnect.
on the big. So we have breakers in the panels, okay?
Mhm.
And what do the breakers do? When the current gets too high, they pop and they make everything stop instead of setting the house on fire, right? Remember
Yep.
that? That's the
Mhm.
breakers in the panel. Now,
Okay.
disconnects, right? They do the same thing, but for mechanical equipment that consumes a lot of amperage. Because what do we want to
Mhm.
do? We want to stop the equipment, we want to cut it off at the equipment, not at the panel when it's this much current going through it, right? We'll fry our panel, we'll set our house on fire. So
Yeah.
large pieces of mechanical equipment, HVAC units, air handling units, even ice makers, things that consume a lot of, that need a lot of amperage or current, they're going to have disconnects, which are these little boxes. That's the symbol for that.
Okay. I got it. Okay.
Okay? So the whole purpose, again, of the disconnect is to cut the equipment off if there's a problem with the equipment and if it's overheating or whatever. We want to cut the equipment off at the equipment.
Right away. Set it off.
Right. Instead of letting the equipment stay connected, and if it's too high, it's going to set something on fire. Now we got to wait till it gets to the box. Because also, at the same position, if you look at the panel, there's a breaker there too for the mechanical equipment. So let's go to, where are they at? So let's see. Condenser, yeah. See, there's breakers there too for the condensers.
Yep.
So the big mechanical equipment has both disconnects and breakers. Okay, where the outlets, the outlets, they just have breakers. It really depends. It really depends on, and let's look at some of the other, like the shunt trip, that's a breaker.
Okay.
Yeah, we got some kind of breaker in there. So the large pieces of mechanical equipment and like an oven, convection oven, that's for a restaurant, that's not like our oven. That's
correct.
Like a big, And so, yeah. And the whole concept of that is we want the equipment to be cut off at the equipment instead of at the panel. So that's why we have the breaker. All right, so you got got our kitchen, right? So now we know how to, because I think you got a Denny's. There's a Denny's, okay? I think second project is a Denny's. So it's the same. Okay, you want to go right to that schedule to determine if you can count your outlets from the schedule first. Notice what the tags are. Notice how they represent the tags on the plan and say, okay, I've already counted everything that got that symbol. Everything point, I already counted. So now I got to look for ones that don't have that symbol and count what those are. And these are two GFCIs that are both JZ chain. We can do them together with MC cable, and they're going to be home run to panel D, position 37. Okay, now, one other thing I noticed when we were doing, I recorded this actually, this part. If you go to my YouTube, like this morning, it's an hour and something, I recorded the takeoff because we had a big problem. On the panel, on the floor plan, it didn't show us where the panels are. Okay, so you can't run a power feeder to a panel that you don't know the location. That's correct. It's like, okay, I'm stopped right here. What do I do? And I looked up every sheet. I went through everything. And so I finally emailed the client. I'm like, well, where is the panel? Do you know where the panel is? Because, this is a, how you go in the McDonald's that's got something on that side and they're selling something over here. So the panels are in a main portion for for the McDonald's, for the Charlie's, for the KFC. Yeah. They're all somewhere in one location. And the electrician is running everything, So I was like, well, where are they? Because they're not here. And so he said, oh, they're up and to the right about 40 feet.
Oh.
Okay. So what does that do for our home? Oh my God, Jesus. Okay. So what that does for our home, I gotta say God and Jesus. Okay. So what that does for the home run, and I want you to think, because I'm going to do that after our class today. I'm going to do this, and I'm going to put that on YouTube too to show you. So what I normally do when we don't know, and we know, okay, it's 40 feet away. So what I'm going to do is I'm going to run. And remember now, okay, and let's just do it here now. Let me make sure everything's to scale. So the first thing you do now, all we have left on this plan are home runs. because these are the only MC cable kind of things. So everything else is a home run. Okay, everything else. And where is it going? Well, these actually can be MC cable together because it looks like they're going to the same position in the panel. And so let's go ahead and do that one. So we'll put those two together.
Okay.
And I thought I looked okay. So we just want to make sure we don't have any more of those situations. But you can see here that this outlet's going to be home run to position 29, panel C. This outlet is going to be run to, you follow the arrow, position 28, panel H.
Okay.
Now, this is a disconnect. It's telling us, well, the disconnect for the exhaust fan. That's what that EF1 knew. It's going to these three positions in panel E. But they're giving us the wire configuration because remember our typical, this is so good. This is a good one. That's why kitchens. You put a whole bunch of stuff in line when you do kitchens. All right, let's see. So on your equipment schedule, right? It gives you the branch circuitry. So basically the home run circuitry. Okay, so not only do you have to count, make sure you got the NEMAs right, but now you got to go through and say, okay, which home run is something other than what? 2 number 12s and 1 number 12 ground and 3/4-inch conduit, because that's the standard. Like you'll see 2 number 12. Okay, I don't have to worry about that one. Because what's that tell my mind? Well, the home run, let me go back to what I should tell my mind. I should tell my mind to look for all of the home runs that are not, right? 2 number 12, number 12. Because everything else is, in general, you know? And so what you have to do now is go, so let me go out. So what C025, whatever that is, 6-head fryer. The home run for that is 3 number 6s and 1 number 10 and 3/4-inch. Okay? So I need to go find C025 on my plan. So I'm going back to the plan. C025. Here we go, right here. C025. So this home run is whatever I just read. 3 number 6s, 1 number 10, whatever. Okay? So that's what you have to do in the kitchen. Go back to your equipment schedule. Which ones are something other than 2 number 12s? Okay. This one, so I got to go, let's see, 2 number 12. Okay. C025. Okay, that one's different. Okay, C130. That's different. C184. That's different. 184 looks like we have 2 going. Okay, that's fine. So if they're branch circuits, then that's the wire configuration of the branch circuit as well as the home run. And let's see. Oh, here we go. N014, that's different. P063, you see? And so what we have to do is like, okay, I'm going to write down which ones are different. So what I have to do, either print this, okay, so I don't have to write it down.
Okay.
Or write it down. And you know what? I'm going to print this because I do it. Actually, like I said, I got to do this. And like as soon as we finish, where's print? Lord Jesus.
Okay.
All right, here we go. So I'm going to print that because, yeah, I need to know. I'm going to print this.
Okay.
Print, is anything different here? Because, see, this is the Charlie. See, that's the Charlie. Those E's and K's and whatever. But all of those are the same. Good. 2 number 12, 1 number 12. Okay, that's good. All right, so we go back here. Now I printed my schedule. So, oh Lord, can I see it? Where's my magnifying glass? Well, yeah, print a little bigger. So yeah, now I can go wherever I need to go. And if it doesn't tell me, you see here, these are the mechanical equipment. So it's telling you. So that's, That's the mechanical equipment. So it's telling you what its home run should be. So I go and do those first. Now, back to the situation where we don't know where the panel is and what to do. We know the panel's right here. Okay, all of the panels. C, H, B, whatever. Okay, I don't care. D. Oh, look at that. All right, D. So what I'm going to do is keep this in mind, write it down, never forget it, because you're gonna have some half A plans like this one day. Run the home runs to here at the end of the building. So every one of the home runs, run it to here, run it to there, run it to there. That point. Then you got to count. How many home runs do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, you've already done the ones that are different than number 12 and 1, number 12. I'm only talking about now all of the remaining runs. Okay?
Okay.
Remember, you got home runs that are, let's go back. These are they call it branch circuit. These are the home runs. Meaning from the equipment directly to the panel. So the first step is to get the ones that are different than 2 number 12s and 1 number 12. We did that, right? So imagine, and again, I'm video talking to myself and redoing this, actually doing it. Okay, so remember, we've already picked those pieces of equipment out, and what in a perfect world, we've already run all of those. We say, okay, here's one we ran it. Well, everything else is what? 2 number 12s and 1 number 12 and 3/4 inch conduit. So then we run all the other ones. So my thing is you want to be as accurate as you can as far as the feeders. We know that the panels are 40 feet basically from this point pretty much. So you're going to run all of your home runs, and the ones that you had to do separately, you just run it right to here. Okay, don't worry about counting because those are separate. Those are different. So run those directly here. All the other ones, run them here. All the ones you know are what? 2 number 12, 1 number 12. So you run them right here, and then you count. And then let's go back because I got it. Like I said, I don't know why I'm wasting my time. And then I'm gonna call it regular home runs. That way I know it's 2 number 12, 12. So I know that 2 number 12, 1 number 12, that one. And remember, I'm running all of these to the position to that point. They'll trick me and say 3 numbers. See. So get rid of that one.
Okay.
Keep counting. So these are the regular home runs, meaning 2 number 12s and 1 number 12 ground in a 3/4 inch. And that's why people lose because they don't know this expert.
Okay.
You said okay. I'm just psyching myself up. That's all. But no, I mean, one of my clients, I did one estimate and he won, and then mad at me because he didn't turn it in on time. I'm like, well.
Oh my God.
You thought you weren't gonna win because nobody wins the first time, but they do. They mess with me. So, all right. Okay, so we have 32 of that kind. Everything else is something else. Okay? So what am I trying to say? Okay, so we need to be able to accurately kind of determine where the heck. All right, so we have 32 of those. And so what's that mean? That all of these outlets that are just regular, we have 32 and we ran them to here. So now I need to do the additional to here, right? So what I'm going to do, I'm going to say 32 times 40 is the additional linear feet for the home runs for those. You get it?
Okay. Yeah.
Okay, so that's how you do that. When you don't know, it's like, okay, well, I'm going to run, and you could have ran it to like here and then done that. I mean, whatever you want. But no, he did say upper right 40 feet. So that's the best I can do with that. From the end of the area, right 40 feet.
Okay.
Okay, so do you get the concept of what we just did?
Yes, ma'am, I did.
Okay. Any questions?
None so far.
Okay. And so now when we are running, so let's do this one. Let's start to run for the next couple minutes. The ones that, okay, good. Let's run what we do see. Okay. And that's pretty much my technique. I'm going to, in terms of running the home runs for the ones that they're telling me right here first. Because you're going to have a mess, okay, no matter what you do. So it's just like how do we eliminate the mess? And so I'll do this one. 2 number 10s. Number 10. Or I could have just said 3 number 10s, to save my fingers. Because it's really the same thing. And I did 10 after number. All right. And 3/4 inch. So, until you get expertise level, about everything. Okay, so basically, I'm going to take it from the point it's showing me. And then I like to do everything like, in one direction, one way. So here,
right.
And then I know the panel's here. That one's done. Let's see if we have any more that are 2 number 10, 1 number 10, 3 number 10, 3 number 10, 3. Everything's 3 number 10. You don't love me. All right, here we go. But that's why, All right, so let's do this one. 3 number 10s. I'm just going to do 4 number 10s because it's the same, really. 4 number 10s and 3/4 inch. Okay. Same. And then condenser, I'm assuming it's on the roof, and the panel is not on the roof, and so I'm gonna get out of 10 feet. Okay, there's that one. Oh, look, we got a few that are 4 number 10s. Okay, so I did that one. Now we're gonna do that one. Let me go back to that. Okay, so we did that one, and kind of separate so you can see that you've done one and don't have to kill yourself to see. Oh, damn, did I already do that?
Okay.
Same thing. Add 10 feet. Okay, so that one, this one. Okay, we did those 3. Let's see if we got any more like that.
So each run you do, you add an additional 10, correct? I remember you saying that last time.
Right. Remember, and that's not for everything. You got to think about where is the condensing unit. It's on the roof, right? It's up there, but the panel's down here. So you want to make it across the building and then bring it down only because that's the only run. Like with our other home runs, we won't do the same thing because we're going to do like 1,000 feet, and all we're going to do in the end is add 10%, and we got that covered, right? But when you're only doing one run, right? You're not. I don't add 10%. I just go ahead and do it like it's real life, and give it the normal 10 feet. Give it, which is a little extra than it needs, but at least that to me is okay. I've covered everything that piece of equipment needs. Because it's a unique, right? It's a unique wire configuration. So it's not like, oh, I've got like 1,000 feet of that. I want to make sure I cover that completely. So yeah, and you got to think, okay, where is the piece of equipment? It's on the roof. So yeah, we got to come down. So, and again, we don't do that for the outlets and the switches is because by the time we do all the home runs, we're going to have 2,000 linear feet. Let's just add 200 feet. That's probably too much, but we're covered. See, that's my thinking on how. Some things you add the 10 feet, especially if you only have that's a unique run. You only got one of them, but we had 3, but it's still not like we had, 32, like these home runs we get ready to do. You know what I mean?
Mhm.
Okay. So, I mean, that's as far as running the wires, what you're going to look for when you run the power or what's the home run, or what should be like this. Well, you're going to look at what panel is it going to. If they're going to the
Mhm.
same position on the panel, then I can daisy chain them together, and then I'm going to run the home run there.
Okay.
Okay, that's what you want to think. Same position, yeah, I can run these together. But yeah, I know run these together. But no, that's different. That's different than that. That's different, different, different. And if they're going to the same panel position on the panel, chances are they're really close to each other.
Mhm.
Like these are, or
Right.
even these that I found. At least
Mhm.
it's like okay. Well, these are 37. Those are 33. And so you want to take a quick look. Is everything going to a different position? And as you can see here, even if you wanted to do it like I do, which I'll do, is I'll do all, and I probably won't because this set of plans is so bad, but usually I'll do how many linear feet of home run is going to each of the different panels.
Mhm.
Is that what's that? Panel C, panel H, D, and then I think I saw a B somewhere in here. So I'll do, if I saw the panel, if the panels were where I could see them, then yeah. But this way, yeah, this is like a shortcut way of fixing this pain in the butt where they don't really show you the location of the panel.
Mhm.
But that, imagine if you left that out though. All
Yeah.
of that because 32 times 40 feet is the
Yep.
additional home run. So whatever that math is, right? And we're talking two
A
number
thousand
12
feet of maybe.
one number 12 round, and so that's actually 3 times that much in number 12 wire, right? Because inside of
Ooh.
that one length is 2 number 12s and 1 number 12 ground, right? That's what's inside that one length of conduit, but that's quite a bit of underbidding. Okay.
Uh huh.
So what I want you to do in about an hour, hour and a half, because I'm gonna get on this as soon as it's almost. I only eat once a day, and it's usually at 12. So by 11, I'm like, oh my god, I'm gonna eat my own fingers. So I'm gonna have my lunch, and then I am going to do this and make sure it stays fresh on your mind because and I'm going to review that. I'm going to record that and put it on YouTube, so you'll have this recording privately, and you'll also have that one, so you can put those two together. I'm telling you, you can start to do the wire runs. It's the
Okay.
same concept. If you don't see, if they're not going to the same panel, then they're home runs. Okay, so
Mhm.
figure out where the panel is and do your nice little way of home running. And again, you're not trying to get the exact number, you're trying to give it an allowance that makes sense based on these
Mhm.
plans. So if you had to actually run the wire, you wouldn't run it all this way, right? You probably go straight to it. It's probably
Mhm.
required that you go and be very neat. And you say your husband's very neat, so I'm sure he's
Yeah. He
going
is.
straight to it the way he's supposed to, and making the angles the way he's supposed to.
Yep.
Okay, and you know, so think about that. Review this because it's going to be available like an hour after we get we finish. It does whatever it does. It takes about an hour to come back to me finished. So I'm gonna get that to you, and then now I'm going to do the actual home runs and I'm going to break them down so you'll be able to see that. And so next week, what's due is just your takeoff now. Now, the counts for that first little, and I think that's like, I don't know what that is. I couldn't determine if that first project, it didn't look like it was a kitchen, but I think it's just like an earring shop. It's a really small, first project, but
Yeah. Small retail. Mhm.
right, right. So what's due next Wednesday is just the takeoffs for the counts
Okay.
and all wire and try doing the wire runs. Okay?
Okay.
And why not? And then we'll talk about all of that next week. And on
Okay.
the homepage, if you go to our homepage, At the very bottom, you'll see a schedule where you can set a schedule of times where we can meet. So start to look at that, and you can even schedule out in advance, because if you need extra time other than this, just let me know, and I'll make time. So
Okay. Okay.
all right. So I'm gonna
Will
close.
do.
Okay. You have any questions though?
So far, no.
All right. Good. Is everything? Is it making sense?
Yes, it is actually making sense. So I feel a little bit more comfortable now. So hopefully that's going to be my goal, is later to start on that takeoff, because
Yeah.
I want to see what happens after you do a takeoff is my thing.
Yeah. Oh, yeah, yeah, yeah. Definitely. I mean, and remember, you have those videos, so you could go ahead,
Yes.
because
Okay.
do the estimate, and I'm working on just having just a whole bunch of just videos that I've done on my website, and so you'll
Okay.
have access to that. So I'm working on that too. So you'll have access to that indefinitely. So that's why I
Okay.
try to do
Good.
all the different types of projects. Or like, okay, kitchens. All right, they're a pain in the butt, and here's why. So you can always go
Yeah.
back. If one kitchen is the way they build them. One's just the same as the other one. It's just the way that you think about it before you start the takeoff, so you don't waste your time. Same thing with the hotel. It's a way to think about doing that takeoff before you actually do it, and you'll save yourself like 10 hours. Okay,
Okay.
so I try to start you with the kitchen, because that is the hardest thing to kind of work
Yeah.
through.
No wonder he doesn't want to get kitchens too much. He really doesn't aim on restaurants, but I keep telling him why not, But he does say it's a lot more work.
Right, exactly. But then again, it's a lot more money. Working.
Exactly.
But if he feels confident in the estimate, you know what I'm saying?
I think that's his problem. He doesn't feel
Yeah,
confident.
right, right. And you don't want to give away the boat, but there's a
Yep.
mathematical way, as you can see, that we're learning on how to do it. Step A, step B. You can't miss. You can't miss, and especially
Right.
when you have the cost book that tells you how many man hours. So you
Yeah.
know how many hours something's going to take. You know how much you charge an hour. So does that feel right to do that job? And yeah, something like
Exactly.
this, you have to run 32, 50 separate home runs. Yeah, that's a lot of
Hmm.
labor. Okay, that's
Right.
different than a building where everything's daisy chained and you got like maybe 5 home runs. Here you got like 50 home runs, and so
Hmm.
yeah, that's a lot of labor. And so yeah, if you don't price it right, no, I don't want to do a kitchen. Yeah, I want to do a kitchen because it's some good labor, and I'm getting,
Right.
I'm not lowballing myself. And so he'll be
Exactly.
able
Yeah.
all the different types of. That's why I try to give a good variety in the study set of all the different types to see. Okay, yeah, some things are a lot more labor intensive than other things. You know,
Right.
yeah,
Yep.
and kitchens are definitely one of them. So yeah,
Mhm.
okay. Now you can
Okay.
convince. You can do it. So you can
Right.
estimate. You can do it. That's right. All right. So
Okay.
yeah,
Well.
later today, and please let me know if you have any questions. Okay.
Okay. Will
All right.
do. Thank you so much.
Thank you very much, and I'll talk to you soon.
Yes, ma'am. Bye
All
bye.
right. Bye bye.
This conference will now be recorded.
All right. So in this, what we're going to do now, I'm going to kind of go piece by piece on your takeoff. But what I'm going to look at is your electrical, not the power plan, not so much your lighting plan, but we'll do that separately. Okay, so let's do that first because that's really the easiest. All right,
Mhm.
so when you are now, what we're looking at, these are the lights, right? And so
Mhm.
I'm going to do this too because my takeoff for this one's on a different computer, but I'm going to do it on this one now, so it'll all be together. Right. So for the lighting plan, the first thing we're going to do is, oh, look at me. I haven't used my version in forever. I have it on a couple of different computers, so like every month, especially this one because I just bought it, it tells you. Come on. Okay, there we go. See, 30 days. Why? I paid you. It's not like, oh, I'm waiting to get paid. Okay, there we go. Oh, these people. They just want me to buy an unnecessary update. So I hope you guys don't fall into that. Anyway, we'll talk about that later offline. All right, so DL2. So all we do is count, right? And so you were saying you were having problems with Plan Swift. That is just going to take you practicing. And remember, we're only using Plan Swift for a counting tool and a ruler. And so all you really need to master is the count tool and the segment tool. That's it. And over this class, we'll do that. So okay, so we're looking for DL2s. And so, of course, the line in between, and remember when we were saying the last class, sometimes they show you the connecting, the wire to connect the lights, remember? And then I was saying sometimes they don't. Well, this one does. So this makes your life real easy in terms of determining. Now, remember, on all of the plans, you have to determine your MC cable, basically, because they're allowed to use MC cable to connect these runs as opposed to. So they have two choices, right? The MC cable or the wire configurations. Okay, what do we mean by that? Wire configurations. When we know that we have like two number 12s and one number 12 ground in a 3/4 inch. So anytime you hear me say wire configuration, that's what we mean. MC cable is like cable, like your telephone cord. It's already has the wire already in it. They don't have to run it separately, but they can use it for these connections. Okay? And so when you're doing your wire and conduit runs on every set of plans, you're going to look for what's my MC cable runs, which are all the interconnections, and what are my home runs, right? You always have two things. You always have, because these are all connected together, but then, of course, it's got to be run to the home run, which is the panel. The panel is the power, right? So at the end of the day, all these can be connected together, but they've got to go to the power panel, okay? So when you see the home run, automatically in your mind, that is automatically two number 12s, one number 12 ground. That's not MC cable. Okay? All home runs are that number 12 configuration or something else. And it will tell you what the something else is.
Okay. Hello? I cannot hear you. Hello? Hello?
Oh, is it back? Okay.
There it is.
All right. So I get okay, good. So it stopped recording and everything while I was. I don't know what happened. I just lost my phone all of a sudden. So okay.
Yeah, I
So
just heard it.
yep. Good. 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 Okay. So let's go back to counting. The counting part is easy. Okay. And
Mhm.
so as long as you make sure those are right. And now I'm just going to do this real quick for this plan. So I'm not going to even finish counting everything, but I will. Just for the
Mhm.
interest. Okay, so remember, all the interconnections are either MC cable, okay, or all of the conduit and wire you're going to be concerned with is either what's MC cable and what's a home run. These are always home runs, so that's always going to be, again, the number 12 configuration of wire or something else. But if it is something else, it's going to be like a keynote there telling you what it is, okay?
Okay.
All right. Now, one thing to remember too, so remember your electrical, you have your power plan, which is everything that needs power and all the power components. Then you have the lighting plan, which is all the lights and how they're controlled. And so what you'll
Okay.
always notice, and don't be confused, you just have to go back for reference and find out where it is, because remember, for the home runs, you have to run it to the panel.
Mhm.
But on the lighting plan, they don't really show you where the panel is. So keep that in mind. So you always have to go back to let me take all of this off too, because we're going to work on this takeoff piece by piece. So you always have to go to the power plan and for reference, find where the panel is, go back to the lighting plan, and make your measurement. Okay, so let me just cut everything off. All right, so power plan shows you all the power components and where the panels are. So I don't even remember what the panel is. Okay, so here's the panel. So what you have to do is, so my whole point is you have the power plan and the lighting plan. The power plan's job is to show you everything that needs power and to also show you where the panels are. But on the lighting plan, it does not show you where the panel is. That panel is where? Over here, right here. Okay, that's not the panel. That's light EM2. Okay, and so when you're running home runs, you have to just go back to the power plan and kind of make a visual of, okay, it's in wherever this, you got to look for that symbol maybe, because it's inside that room. Okay, so that's the panel, lighting contactors, and contactors for all the lighting controls. Okay, so you were mentioning there's no ever a part number. Because these are made in such different ways. You can have a 4-pole, 6-pole, 8-pole lighting contactors. But on the plan, it's going to show you, where is it? Probably going to show you on the lighting plan, because those are used for your switching mechanisms. Okay? So your lighting contactors, see, lighting control, automatic lighting control, your time clock, your lighting contactors, okay, and however the electrician has to arrange it. But this is showing them how you arrange or how you connect it together. Now, what C1 is, we'll go to keynote number 2. Okay, so it's a 20 amp electrically held lighting contactor, provide number of poles as required with at least one extra spare. Okay, and so this is like a contractor specific. So you tell your provider, your equipment, they know what that is. So those are specially made, and it says too, provide the number of poles as required. Okay, and so what this is all of the lights, right? So remember, this is the lighting contactors, and this is just showing how the lights are connected. So it itself has to be connected directly to the panel. Lighting contactor has to be connected to these
positions in panel L and C, the electrician has to determine. In this case, the electrician has to determine what the configuration of each of the lighting contactors are. Okay, and even on the lighting plan, right? Remember, no panel. They're not going to show you where the panel is, but we know it's like right here, or right here. See, now I forgot. In the stock.
It's right about there.
Yeah, right there. And so when you run,
uh-huh.
and so let me go ahead and you know when you do your counts, you don't have to worry about it being to scale. But once you do, hold on one second. Oh my goodness. All right. I don't know if that worked or not. All right. So you know, when you do your counts, you don't have to set your scale, but when you start, you know, you measure your lengths, you do. So just make sure, you know, you always do that. And so in terms of the home run, so you know with the MC cable, okay, so we can call it MC cable. This would be the easiest part for this one, you know, because again, the plans are to scale. The architect makes the plans, right? And so when I just do this, I just follow the line, and this is the MC cable, okay? And so whatever it is today, it is, and you don't have to be so perfect, you know what I'm saying? But give it, you know, something like that, you know. So that's what that looks like, okay? Nothing too crazy. But for the home runs, and I used to get in the practice of if I have more than one panel, I'll say home run panel, whatever. So I just like to do it that way. In the event that the electrician ever questions how many linear feet of home run, then it's like, look, I broke it down per panel. You know, so that might make them a little easier for them to understand all of your numbers in the end. So the more detail, basically, the easier, the better for them to interpret your takeoff. So you always want to give as much detail as possible, okay? Now, remember, these numbers are they have to call the lighting control something, right? Circuits. They, you know, circuit A, B, C. This has all the way up to K, it appears. So what does that mean? It means that they have their lighting controls are, you know, any configuration. So A, B, C, D, E, F, G, H, I, J, K, that's 11. So basically they have like 11 different lighting control configurations. Does that make sense? Where A is connected to, I can turn on this set of lights at one time. B is, I can cut on this set of lights at one time. C is, you see how that goes?
Okay.
You said okay. So and remember, when you don't have, so look at this very carefully, because when you don't have, like our example, when we did the first example, when you don't have the wire connected showing you how the lights are connected, but remember I was saying, you're always going to connect it based on all the K's, all the G's, all the E's, this is telling you exactly that. Right? All the E's are daisy chained together.
Okay.
I'm saying in terms of the lighting control, this is lighting control. These are the sets of lights that are controlled by circuit E. That's what we're trying to say. These are the sets of lights controlled by circuit G. Right? So remember, when you don't have the lines very detailed like this, remember it's the same thing that applies when you don't have the lines. So you have to create your own lines. They're giving you the lines, right? But just know that's what this means. G's. This is not even next to this one. But they give you the G, and then what is it? It's daisy chained together, because all of those lights should be turned on or off at the same time. That's the whole purpose. Okay? You get that solid in your head, because sometimes you're going to get the lines that show you how to connect the lights, and most times you won't. And so you have to be able to run wire for the lighting, right? And the way the plan tells you to do it is you have those lowercase letters.
Okay.
Lowercase letters tell you which lights should be run together, okay? Don't ever forget that. That's major, because depending on how much they spend on those set of plans, they're going to give you detail, not going to give you detail, okay? And so you really have to remember that. So wherever there's a G, just get to, running them all together. And usually, and note from this example, in this case, how many home runs for all of these E lights? How many home runs? They only have, let's see, all of the E's. That's E's. And see, it stops here, it becomes the C. But then the E, that's a G. Okay, here's the E's. E, E, E. And that's one home run. But you can do that with light fixtures. You can't do that with outlets. Okay, with outlets, you can't have no more than like 5 or 6 daisy chained together before it runs to a home run. You can do that with lights. So just know, let this be your example. Is like, okay, if I didn't have the runs already showing me, how would I run the lights or run the wire? Just like this. And see, here in this case, you have to leave it to the electrician. Would I run just a home run or something from here? I probably would, but in this case, they're not. But again, with lights, you can do that. You can connect or daisy chain 5, 6, 10, 12 lights without running it to a home run. But let this kind of be an example of what do I do when I don't have these nice little lines to use, okay?
Mm-hmm. Okay.
And so as far as the home run, I would just do something like this, because we only have one panel, so I don't really have to worry about that. So the home runs, and I would actually call this lighting home run, and we know the panel was like right here somewhere.
Mm-hmm.
That's probably what this outline is. So that's that home run, and then this one, I'd run it like that, and then this one, and I think that's all the home runs on the lighting plan. Oh, yep. Okay, so everything else is this MC cable. So you just nicely follow all of the lines that they give you. And see, I'm so lazy, I'll go all the way across and then go like that. And then that's not gonna hurt you. That seems faster to me.
Yes, ma'am.
Okay, so that's that. All right, so now what we're gonna go back to is this one. Okay, so I looked at your takeoff, and the first thing you said dupes were 15, which you're right, but you got to make sure that you follow everything. So those that I counted 12.
Mm-hmm.
Okay, but and then 3, so that's 15. Okay, but why did I separate my other 3 is my question, right? And so you have to make sure you do the same thing, and make sure too, if there's a keynote, next to what you're counting, make sure you read that keynote, because it may be very important. Okay, duplex in wall, unless noted, low profile. Okay, you don't care about that. You just know it's a duplex outlet in the wall too. But then we have these 3, this number 3, and what is 3? Duplex in the ceiling above display window. Okay? And so you wanna note the difference between the ones in the wall and the ones in the ceiling, because it's more labor. They have to do this kind of like bar to keep it up in the ceiling, so it's not as easy as it is to install it in the wall. Okay? So that's the one thing you want to make sure is you always want to make sure you know or you read the keynotes, even though the symbols look exactly the same, right? They are. Okay. They're in 2 different places, and the keynote. Mhm. Okay. Okay. Keep that in mind for just about everything here. If it has a keynote, even though it's the keynote may not make a difference, but you want to make sure. So let me look at 11 and 12, because I didn't seem to let those make a difference. So let's see.
Okay, so this is like one for the TV. So it's not in the ceiling, right? But it's a little higher
Mm-hmm.
up on the wall. But I didn't even make a difference for that, which I should have, So it really depends, because that's basically in the wall for me. You know what I mean?
Yes.
Yeah, but it's just now the electrician, yeah, she's gonna go in there and see, going through each keynote to make sure, yeah, where do I put this, and they have elevation views and everything like that, so they know the height of where everything should go. All of that's in the
Mm-hmm.
specifications. And two, you got to get back with me if you want to take the basics class. Remember that? Remember we talked about that?
Yes. Yes,
Yes.
ma'am. I gotta tell him. He's been crazy busy, and then he doesn't sometimes help me. I ask him to help, and I'm like, he leaves it all on me, and I'm like, I'm stuck, and I'm like, oh my gosh, this is horrible.
Tell him
And I tell him, you need to help me.
don't help you because the electrician and the estimator look at the project from two different perspectives. And
Oh, no wonder.
he could just worse for you.
He's just hard on me. He's very hard on me. He's like, you gotta learn this, and I'm like, oh my god, it's hard.
No,
I'm trying.
Tell him to back off. Back off. We got yeah, because he's
trying to scare me and make me quit. I already told him.
I have another husband-wife team, and he was just like, well, what about how many boxes and covers? And I'm like, no, we don't care about that at this point. You know what I mean?
Right.
It's just counting the assemblies, and that's why I think we need to do a basic class. So you can go from the general, because you're really going very specific, but we didn't go general. And we need to go general before you can go specific. So talk him into that so we can take an hour, 2 hours to do that separately.
How much is it?
That's $199.
Okay, I'm gonna let him know. If not, I'll pay it myself.
I'll bring that up to where we pay half, ASAP, because the other half of the class is due in maybe 2 weeks. We just added to that.
Okay.
Okay, so yeah, talk to him because I think that would help. All right, so now just make sure that no matter what you count, especially on the power plan, if they give you a keynote, and you see you have a zillion of them, right? And so what I normally try to do is, and you can with PlanSwift, is get really up in there. You may have to print like 5 or 6 pages. But then you go here, and then you go, now I ain't got my glasses on. Print, and then remember this bottom one.
And I actually did that not long ago for the symbols on one of them.
Yeah, good. Yeah, for the power plan, make sure you do that because it's kind of a pain in the butt. Because like here, 56. Location of Wi-Fi to provide 3/4-inch conduit at the location shown from the TBB, that's the telephone backboard with pull string. And so, what does that tell you? Well, you should have some physical length of 3/4-inch conduit for the Wi-Fi, wherever 56 is. Okay, so wherever 56 is, I think we got a couple of locations right here, maybe 56. So this right here, this is the Wi-Fi, how they have Wi-Fi in there. And what that says is 3/4-inch conduit from here to where the telephone board is. And it's usually, it's going to point out where it is, but it's usually the telephone board is usually by the panel. Okay? And so, yeah, you got to keep that in mind. And what's 54? And what I know for certain because, yeah, right here, I did mine, right? All of the locations, based on the keynotes, right, require 3/4-inch conduit. So what I'm going to do is I'm going to send you my takeoff for the power plan because seriously, the power plan is, it's the most difficult and it takes a lot of time, but you got to make sure you go keynote by keynote
And with this one, I think they gave you one keynote per whatever. I don't think they doubled up. Oh, yeah, they did. Yeah, they did on the 50. Oh, maybe not. I don't know. But they may. They double up on. See, I think one of these 57 was just quarter-inch conduit to the ceiling or something. I didn't. Those aren't even count. I don't know. Oh, yeah, because I only have one of my dots on. But you see, you got to make sure you're not only counting, stuff that you can see the symbol or whatever, but a part of that too is, okay, what's number 6? Let me make sure it's not something, just like 54 and, all of these locations. Now, this is telling me to the telephone board. So not only does this tell me I need that, whatever 54 says, all of the other locations, even though they didn't give me this outline to follow, right? All of the other locations had that same requirement. 59 and LV, what's LV? That's low voltage. Okay, so it sounds like a lot, but it is a lot. But everything, it has a number, and it's, that's why electrical estimates is like your husband, I don't have time. Well, this is why, and to be accurate and detailed, it takes you more than a flooring estimate, okay? We can do flooring in 20 minutes. Okay? Oh, man. But flooring don't get the big, electrical gets the big bucks, though. You know what I mean? So
yeah, I see it, but it's a lot.
It's a lot, but keep in mind, if you break it down, part 1, part 2, part 3, you'll be fine. But the biggest part is keynotes, especially power plant, okay? So here they give us low voltage notes, okay? Because the electrician that provides the panels and the outlets and all of that, you can be the high voltage electrician or the low voltage electrician. The low voltage electrician handles stuff like the telephone and the Wi-Fi connections and outlets, but the high voltage electrician, like your husband, provides the junction boxes, right? And then the TV person, the Comcast person, will come and put their outlet, right, in our junction box that we've already provided. And we will also provide conduit to hide their wire from the outlet just to the ceiling in commercial. And so from the ceiling to the box or whatever, that Comcast handles all that part, okay? But as the high voltage electrician, it's our job when we see low voltage notes, we have to read those too, because we do have to provide junction boxes, and it'll say or whatever, right? And conduit. Anywhere, anytime you see conduit, that's you. That's something you have to pay attention to, even though it's a low voltage scope of work. So the high electrician works with the low voltage in terms of providing all of the junction boxes and all of the conduit, you see, of all the different sizes for whatever that, transmitters, here's another one for speakers, right? Got to provide that for speakers. Here's another one for the security keypad. The electrician has to provide conduit for that. And here's another one for cameras, the conduit for that, okay? So here's another one, some kind of box in the wall, signal box by others, okay? So the recess 2S box, that's by somebody else, but we have to provide the conduit. They say the pull string, when the electrician is only providing the conduit, right? There's something that has to go in the conduit, just like our wire goes in the conduit. But when the electrician is providing the conduit for another trade, for the security cameras, for the Muzak, for whatever, they also have to provide the pull string. And the pull string is what? It's basically the thing that pulls the wire through the conduit. And so
and pull string. You always see that, and that's why. Because that trade has its own wire, right? The HVAC person, the speakers, they have their own low voltage wiring. See, we do high voltage wiring. The speakers, that and whatever like that, and computers and telephone and all of that is low voltage wire, and we don't do that, but we do what? Provide the conduit, and then we provide a pull string for them to pull their wire through it for their systems. It's a lot, but you're going to be so good because I didn't know a thing. Well, I did, but not like this. Okay, so it just takes to, just to do just to do the estimates. And, like I said, with this class, you're also going to have access to a lot of the different ones I've already done. So whether it's a kitchen, like we talked about last time, and this, I don't even know what this is. I've tried to figure it out. I think it's just, they sell it or something. I don't know. It's not a kitchen, as you can see. So it's really easy. First one, but again, the power plans are never easy, okay? Because we have to power everything from the outlets to now we've got to power up toilets, right? And sinks and stuff, and all of the equipment on the roof. And so the power plan is never easy. And so that's why you want to take a couple of days just to do the power plan alone. What I normally do is count everything first, okay? Everything, even the switches. I'm going to count everything I see on here. But when I'm counting, I'm also going to take note of what the keynote is telling me. So if it may be important to me as the estimator, it may not, but you have to read it. Just like you want to determine what outlets are in the ceiling as opposed to the ones in the wall, okay? And all of your conduit and stuff, all of your notes are going to give you that. And then the junction box for the primary sign, and then it's a home run directly from that junction box. And so now, on the power plan, it may give you, like here, okay, like the lighting plan, it gives you all, EMC cable still applies to these connections too, okay? So you're pretty good as far as not having to guess how to run your wire on this one, okay? But you know your home runs are going to go right to this little black box right here. And so, and I'm going to send you mine too.
Okay. So when you do your takeoff, that's counting absolutely everything, right?
Yeah.
So like counting, lighting, power plan, everything, correct?
Everything. And I'm going to either upload my takeoff because I'm going to finish the lighting plan, and two, last step on your takeoff, remember you got to count all of the breakers. Okay, so I believe now, remember, it could be an existing panel. Oh, no, this is a new panel. So you could just go ahead and assume and know that. And this is easy because it's telling you right here, 50 amp 2-pole.
Okay.
So you're just counting where you see it. 20 amp 1-pole. We got to know that too. And remember, you have two sides. It's a 42 position panel. That means it has 42 positions. And right, each position tells you what's connected to the home run. The light stock room and the toilet emergency lights. So you can physically look on the lighting plan, and I'm sure there'll be a home run that says L, whatever this is, L32. That's how the electrician knows where to run that power to because what is this? The panel is the power, right? When we say panel, we're saying the thing that is bringing the power from our public utility into our building. Okay, so the panel board, this board is the intermediary, right, between public utility, all of that very high voltage wire that comes in, and then us bringing it into this panel. And this panel gives us the ability to break it down into, you can have an 84 position panel, you can have a 30 position panel, 24. It really depends on what equipment you're trying to power in the building, how many panels you have, or how many positions you have in the panel. So the electrician's job is the electrician, the electrical engineer, right? The electrical engineer determines the size of the panel because there is a certain equation that you use, okay, to determine, okay, the lights and the signs, that's going to take 34, 18-volt amps, and the outlets take up this much, the water heater, that much at 100%, it's going to use that much, okay, voltage per amp, I think, largest load at 25%, okay, so they know how much power the building needs to run properly based on everything that's in the building. And so the panel board just tell the electrician what gets connected at each position on the panel based on what the electrical engineer has designed. It's all a design of the electrical engineer. The electrician understands it and just, comes and physically puts it all together. Okay, and so, yeah, we got to figure out how many of the different types of breakers we need. Okay, this much we don't really care about. Sometimes if you don't know the wire configuration, you can look on the panel. Sometimes it'll tell you. I've had some luck with that. Okay, so the takeoff, let's go over it again. The takeoff, we need everything from the power plan and make sure you, look at every one of the keynotes to make sure you're the conduit or whatever. Okay, so all the counts, all the linear conduit and wire runs, and all of the home runs, and then all of the MC cable runs. Okay, and some things are underground, so make sure you note what's underground. Let me see. Underground, let's see. Okay, so if you read Keynote 10, you'll know that that's underground conduit. You should see underground, I call it UD, 1.5-inch conduit. Okay, because that would be PVC. Underground, we use PVC as opposed to EMT, as opposed to rigid steel. But again, those are generalizations based on most of the projects that underground PVC. It could be something else, but what it is for certain, we learn from the specifications. And I'll have all your corrections made by tomorrow and everything noted on all of the things that you submitted. And if there's anything that needs to be redone, I'll let you know. And to be expanding the office hours, but if you need any additional time, again, you can go to the schedule that's on my home page all the way down to the bottom. There's a scheduling. Click on construction services because there's a couple choices, and then there'll be a lot of opportunities for you to set up office hours with me. Like if you need help after today, go there because we can meet an hour, 45 minutes, outside of this time to help you if you're confused or whatever. Okay, so just look for that today.
Okay, I got one more question. Let's say I'm doing a takeoff, right? I count everything and stuff like that. When you export that, is it just going to have the information for the material? That's all, right? It's not going to have any pricing or anything, correct?
Right, unless you program this, right? On the right side, you can go to, and I've never programmed it, so that's not something, I would say go to YouTube. There's a zillion YouTube videos on how to, let's see, where I don't even see electrical. I think I would. I see plumbing, and I'm not all the way down there. There you go. See it there? And you could just go in and see now, EMT, they give you some choices, but you can go in there and add, right? And then when you do this, that allows you to, like that first one, if you want to price it by the square foot, and there is such a thing. So if you go in that cost book and look for that, there is such thing as you can price it by the square foot of building based on the type of building. So I would say look at that. That's a good test question to test.
How do you want that takeoff? Do you want that takeoff with the pricing as well, or just the material?
No. Right now we're just in takeoffs. Okay,
Okay.
pricing
Okay.
2 weeks. Yeah. We're just working on making sure we can do the accurate detail takeoff. Okay, so just
Okay.
know
Okay.
detail is the key to electrical.
Okay.
And remember, the power plant, like I said before, power plant is going to be the most time consuming and
Okay.
challenging. Okay, and so you have to make sure you find some way to assure yourself that and that you've done every of the keynote. So I started the order and then I stopped. Okay. So
Mm-hmm.
how I do the takeoffs, all the counts of all of the wiring devices, meaning all of the outlets, all of the duplex boxes for data, phone, everything here that's count. That's a count. Okay, first thing. Switches, whatever. Second, I will do all of the MC cable runs. Okay, that's
Mm-hmm.
number two. And then third, of course, I'm going to leave all of the home runs for last. Okay,
Okay.
and how I pretty much do that and leave all the home runs for last, regardless of the page. Even on the lighting, I'll do all of the light, count all the lights, then all the MC cable, and then leave the home runs for last. And not necessarily all within the same day, especially the home runs, especially if you have a lot of home runs, and you
Mm-hmm.
see how I ran the home runs. Okay, that I mean, there's nothing in here, and this thing. Hold on. Okay. There's nothing in here that says, "Oh, run them this way, run them that way." Okay, but you're going to run them in the most logical way. Okay, for what we see here. If it's here, we're going to run it. It looks like this is already almost running it. Okay, that's connected here. Then we're going to run this home run just like right there, or this way, or whatever. But just as long as
Mm-hmm.
everything is neat and logical, like you see here. Okay.
Okay.
All right. Any questions though? Any questions? Because I really want you to go back. I'm gonna send you. I'm gonna send you my takeoff so I can
Okay.
get it to that, so you can compare when you do yours. Now, don't copy, but I want you to do
No,
yours.
I need a.
Yeah, then this is a good guideline. And then if you have questions, like, well, where did you get that? And everything, all my stuff is abbreviated because we don't have 10 million hours, right, to type
Right.
things.
To be typing everything.
Yeah, and I also have a video of this takeoff. Okay, so you'll have the
Okay.
video, you'll have the actual takeoff. Okay, and then my video explains it kind of like I'm explaining it right now. So you'll have it fresh up front and what to do. Okay, I know this is the most difficult part, and it really just depends on how the plans are put together too. How difficult I mean, 57 keynotes. I mean, that's a little excessive. I mean, it's really just a little excessive. Like they could have just put 7 in TYP. That would let me know everything here is the same. No, they put 50,000 times. So
Mm-hmm.
it depends on how they design the plans. But your job really is just to make sure you hit every keynote because there's no
Okay.
telling what you need to do. Some may not apply to you, like 60 inches up the wall. You don't really care about that. You know,
Okay.
you may. I mean, once you win the job and then you start to actually go there, and then okay, well, then yeah, But at this point, no. But ceiling,
Okay.
I mean ceiling and roof outlets, those are different because the roof ones have to be waterproof. And so
Mhm.
if ceiling, yeah, it's additional labor and material to put that outlet in the ceiling. So things like that you want to know account for. And if you have a question when you're doing the takeoff and you're reading the notes, like, is that something? Just email me and I'll let you know instantly if that's something you should be thinking about. In terms
Okay.
of should I add that to the takeoff? Okay.
Okay. All right. I will
So
definitely working on that again.
yeah, no, I want you to redo that. I'm going to send you mine. You'll have the recording. I'm going to put the recording in the somewhere where you'll have it.
You'll know, or just because it's already on like a YouTube format. So I'll send it to you. You probably already saw it. So I'll send it to you with that and my actual takeoff. Work on that. Give me that back as soon as you can, and then to remember by 6 o'clock today that schedule will be set for you to add like office hours if you need additional time outside of class. Otherwise, I'll just look, revise just the takeoff. Now everything, all the conduit and wire, all the breakers, everything lights, everything we talked about, MC cable, links, all that.
Okay. All right.
Okay.
I did have one more question that I guess my husband wanted me to ask you. You're the one who does a lot of estimating and have rough ideas. He estimated a job for duplexes, residential, and I guess his opinion, I guess he wants your opinion. He got his bid for 12,000 and something. He wants to know, do you think that's too high or does he still need to lower it?
Hey, and that's the thing. Everything is different, even if it's the same Starbucks and it's like laid out differently. It could be different in price. The only way for me to know is really for me to do the estimate. So he already won it, or he's getting ready to submit it?
No, he hasn't won it yet. I mean, he's been submitting some bids, but he's not getting them. He doesn't know if it's either his pricing or and he lowered it. He went down to the 10% because he was doing more than that. And he lowered it down to the 10% and then the 49, of course, right? But it's like we're having difficulties for him to get, win these jobs. So in residential, he knows that it's cheaper because he knows a lot of other electricians that do residential, and they're usually bidding like 8,000, maybe 9,000 on duplexes. So he's like, he doesn't have a clue if it's too high or not. He feels it's okay, but then he knows other people that will do it for 8,000.
Well, I mean, the only thing I can advise him to do is just to let me do a couple of them and see.
Okay.
Because
what's your price for the estimate?
It really depends on the kind, on what it is, but I'll give you guys like half off because I really just want you to win one too. And then you'll see, I can win that easy. Because yours is the most difficult thing to bid, and if you don't have a lot of experience, you're gonna miss a lot unless you have somebody that really can help you win until you get the hang of it, And so what I would recommend, I mean, if he gets a lot, if he has one or two coming up, I'll give him a good price. Just tell him to let me do maybe even one of each.
Weakness, I think what he's selling to is one is possibly maybe the pricing, and the second one is his wording, how he sends an estimate out to a client. I think that's his weakness is how to send it, what all needs to be included on there, what's not. So I think probably the best thing is probably have you do maybe a couple of them for him, and then that way he gets an idea of what it is, and so I can get on my feet.
Yep, tell him let me do a couple of different kinds, and then have the hang of it. And two, we could just go over it because I'm just thinking that's all he would need, and it's really difficult if you are doing it on your own, But I'm almost certain. I mean, it can't be any different. Just like my guy in New Jersey, right? He won the very first one I did, and it was mad at me because he didn't turn it in on time. Like, well, how is my? I get blamed for everything. That estimator always gets blamed. So tell him, but most of all, just tell him I won't charge him like I don't know him, because I want to show him that he can win, and then he'll be happy to pay me anything.
I'm sure he will, because right now, like I said, he's bidding on quite a bit of them, and it just seems that we just don't get them. We had one client called us on one of them and gave us a hope, and then turned around and never called us back. So it was like, oh.
Make sure, tell him too, if he's going to have me do some, I want to also do ones that he lost on my own.
Okay.
But just tell him to give me what he used for his lighting and the switch gear. I don't need none of the other pricing, And let me compare. I would have given him as the price compared to what he did. Any of the ones he lost. And I'll do, tell him to give me one of those too. if he sends me at least two to do that he's gonna pay me for, I'll do those for free so he can compare, so he can see.
Okay.
Because I'm
Okay.
telling you, it only takes somebody helping him, especially now that he's on his own, and he could beat out everybody. Kind of just know. So I'd be interested in seeing the ones that he lost and see
Okay.
what I've given him as the price.
Perfect. I will definitely let you know, and then we'll get that because I'm sure he will. So
Yeah.
he's been struggling. He's been struggling trying to win them, and he just can't. I mean, he gets jobs, but it's because he knows it's the DC that we're currently doing. But like new jobs that we've seen on Plan Hub, he gets them, and he just can't. he never wins them.
Can knock them out, I'm telling you. Tell him to go through and send me some that are due or whatever in the next couple of weeks. I will definitely, and then I'll video them for you so you can see what I did, and you guys can start to make a little library of that stuff. And I'm telling you, it's only going to take you, I mean, by this time next year, you guys will be knocking it out. But you got to start somewhere, and then start keeping a library of stuff if you ever got questions. And I'm doing them very detailed, too, so you'll be able to know just where to go to look for just what you need.
Okay.
Okay?
Will do. I will let him know. Yes, ma'am. Thank you so much.
Thank you. And I'll be looking for your stuff, and then I'll wait to hear from you guys, and then, we'll go from there. Tell me it's just a matter of time with him winning. And now that he's lost enough, the gods are going to be with him. So tell him, don't worry.
Okay, I will let him know.
Man, I got to turn these down. I got too many. Yeah, I told you. You just got to get the magic, and you'll be fine.
Okay, I will definitely let him know.
Rest of the week, and I'll wait to get your stuff, and I'll have you all updated by the end of the day today. Okay.
All right. Thank you.
Bye.
All right. Bye-bye.
Okay, so in this recording, I'm going to go over briefly how we go from the takeoff, which is over here on the left, to filling in the estimate. And so I'm going to blow up the takeoff because I'm going to put it on another sheet. And so let's make it bigger, okay? So the takeoff you're going to get from when you finish doing the takeoff, if you're using Plan Swift, then there's a way that you can print this. But basically, this is the takeoff. This is how many dupe outlets, 12, dupe in the ceiling, 3, quad, 3, GFCI, 1, J-box for the data and phone, which is a duplex junction box. We have 1, 3/4 inch conduit, about 360 feet, an inch conduit, about 100, and this is all based on the takeoff, based on the plans on either the power or the lighting plan or both. Okay, so a junction box, data and phone, so that looks like a duplicate of that one. So we have another one. UD is underground power and up, meaning we have it underground, but then we want it to come up at some wall. So we can add the up part and the transition part added to the 11 feet. Underground conduit 1.5 inch and up about 11.5 feet, linear feet, all based on the takeoff, based on the plan. And 1.5 inch conduit to the telephone. And that's about to the telephone backer board, which is about 31 linear feet. Power wire, remember this is the MC cable, it's not the home run. We have about 161 feet. Home run, we have 394 feet. Okay, and so what is that? When we talk about the home runs, it's 3/4 inch conduit. Inside that conduit is 2 number 12s and 1 number 12 ground. So in terms of number 12, then it would be about 900 if we round that up to 300. So it'd be 300 linear feet of the conduit, 3/4 inch, and we know the home runs, unless it's otherwise noted, is 3/4 inch conduit with 2 number 12s for the hot and the cold,
and then one number 12 for the ground. So that's 3 number 12s inside that. So that'd be 900 linear feet basically for the number 12 for this alone. Then we have junction boxes for the power plant, junction boxes for the camera is 6, junction box for the exterior sign is 1, rooftop unit power feeder, 36 linear feet, GFCI outlet, that's waterproof, 1, and then these are all of the light fixtures and the counts. MC cable is for the MC cable for the lighting plan, and then this is the home run for the lighting plan, and these some more lights. We counted occupancy switch in the wall is 1, J-box lighting 3, and then the switches, the override switch, switch bank 111, switch keyed dimmer 1, and other lights 1 and 1. Speakers are 4, although we had junction box for this. Oh no, junction box for the camera was 6, and emergency backup, battery backup is 6. Okay, so this is the full takeoff for our project number 1. And so what we're going to do here is take an existing Excel, and let me get the takeoff over here. Oops. Let's move that over here. Move it to the other screen so I can still see it while I fill in now our sample. Let's make that just a little bit bigger. Okay, and so this is how, well, let's make it a little bit smaller. This is how we format our electrical Excel spreadsheet. Okay, so contractor contact info, best students ever. Now, this estimate is subjected to a final site visit prior to confirmation of cost and is based on plans dated, and I have to check the date of our first project on the plans. I don't have that uploaded on this one, but we'll put that date there. So whatever the date is from the permit date on our actual sheet that we used, or the addendum date for the very last addendum based on the plans, okay? So we used, this is a different estimate. So what we do first, I always do, is I use existing ones that are pretty filled in with everything I need, maybe not so much in this case because I think we need 1.5 inch. Okay, and second part of this is now going to the cost book and finding the prices for ones that we don't already have in here. So again, this is one that we've already done. So normally what I do is I'm just going to call this project 1, but you would put the name of the project and the address. City, state, and zip code. Okay. So remember, this is an existing one we already have. And we'll put today's date, and this is 3/29, 2023. Wire and conduit single line, allowed 100 linear feet. That doesn't apply, so we're going to delete that. Now, we want to zero out everything here. So we put in 10, and then we Control C, copy, Control V, highlight, Control V, highlight, Control V, don't go too far.
And hopefully you can follow step by step. Now for the lighting, it's going to be totally different lights. So we can just delete all of the, whatever those lights were. Okay, we're always going to have a lift, permit fees, and let's add one. So we're going to add a row in between permit fees and lighting package. So let's highlight that. Upper right, insert, row. Now we have to go back and fill in this with the proper equation. So I just copy an existing row, Control C after I highlight it, and then we highlight this row, Control V, and now I'm going to say switch gear. Because we have the material cost down here in a lump sum, but the labor we determine up here. So whatever our panel is, we'll say 1. That's going to be 0 because the material cost is down here under the lump sum for all of the switch gear. But then we determine from the cost book what our labor should be. Okay, so this first part is just filling in, and now I have my takeoff over to the right, but you don't see it, but I'm going to fill it in. Okay, so we made everything zeros, and because this was from, this applies to the existing, the previous, we're going to upper right delete rows. Okay, and then always save. You might get it to automatically save. Okay, so now from our takeoff, our dupes, we had 12, and then we had, it's telling me to free up some space. We'll do that later. Dupe menu board, that's pretty much the same as this dupes in the ceiling. No, it's going to be a different price. So we had 3 of those, and I know just off the top of my head, 89 and 1.25. Okay, so that's 3. We have a single pole switch. That's right here, SW1. And one of those. We have quad, we have 3 of those. GFCIs, all this stuff is usually the same. Always in. Now, junction boxes. Now, this is junction box data phone with the 3/4 inch conduit. So, just normally what I'll do is I'll start to get a piece of paper now. I'll just steal one from my printer. And now I'm going to write out on my piece of paper 3/4 inch conduit because I need for each one of my junction boxes for data phone. So if it's a duplex junction box, I need twice the 3/4 inch conduit. Okay, let me bring that back over here so you can see that. All right. So junction box data phone, that's a duplex meaning 2, but I need a 3/4 inch conduit for each, one for the data, one for the phone, and so that would mean 10 feet for that one, 10 feet for that one. I have one of them, so that's easy. Okay, and so basically what do I need? 20 feet. That's 10 feet for that one. When it's duplex, meaning there's 2, so you have an outlet that has one of the outlets is for data and the other one is for the phone. And so in terms of the conduit that goes from the junction box to the ceiling, I'll always allow 10 linear feet per outlet. And because there are 2, we need 20 feet, okay? And so on my piece of paper, I'm writing 20 to cover the 3/4 inch conduit for that. Now, I'm going to go on to this conduit, which is the same 3/4 inch conduit. Now I'm going to add another 359. You can always round up. And now I'm going to start a new entry on my piece of paper, 1-inch conduit, and this is all EMT. And two, I always assume EMT and PVC for underground. Now, what you always want to do is look in the specifications to make sure. Okay, so I have another entry on my piece of paper, 170, I'll just do 177 linear feet of 1-inch conduit. Okay, so remember, that's data phone, that's duplex 2. That was actually should have been added to this one, so we actually have 2. Okay, so we're going to add another 20 feet. One for the data, one for the phone. So let's go back to our estimate. I'll take that back over to the side. And so, junction box, 2 gang and duplex, same thing. So we know we have 2 of those. I'm not going to put my conduit totals. So this is conduit with pull string. I'm not going to put my totals in here yet until I've finished. But what I will do is add a line. So we highlight it, insert upper right row, leaves an opening, and now I'm going to highlight that. Control C is copy, Control C, and then I'm going to insert it here. Control V is in Victor, Control V. But this conduit, I'm going to say it's for data phone. So we know we've broken some down for the phone, and the other, I know it's for, you could even say for power feeders. Okay. So we fill all of these in after we've done everything, and we won't need a number 3. So we highlight that. Upper right, delete, row. Okay, and then I'm going to save it. Okay, so this is our project number 1, that little small retail jewelry store. We're filling in the estimate from the takeoff. All right, so we're back at the takeoff. So we need these. Let's see. Let me go back over here. We did the GFC, the junction box, data phone. Let's go back over here. Make sure we have the right 2 gang. Okay. Now we also have 3-inch. Okay, one to the junction box, data phone, underground power, and up. So now I need to, on my piece of paper, I'm going to say 3/4 inch PVC, because that's what we use for underground power. Underground, let's see. And we have 11 feet of that, and then I'm going to give it another 6 feet up. So I'm going to add 6 feet to my regular 3/4 inch, because that won't be PVC. And this is all what I'm writing on my piece of paper, because I'm not going to fill these in until I have all my totals. But what I will do, because now I know all of these are EMT unless otherwise noted, UON. But now I know I'm going to insert row. I know I have Control C. I know I have Control V. It's a little extra step. Now this is for the PVC. I need to make sure I delete some files so this won't cut me off. I'm going to be doing that over here to the side in a minute. But PVC and this isn't the same price. So if you do borrow, you got to zero that out. It's not the same price for PVC and EMT. It's not the same price, and it's not the same material, labor rate. So those we're going to have to go back, like we'll have to do for a couple other things. Go to the cost book and find that. But first of all, let me do this while I'm recording to make sure it doesn't cut me off. Let's delete that one. Yep. We're gonna. I don't know what this is. Maybe it's recording right now. Okay. I don't know what that is because that's today's date. All right, so back to our. So we had underground power. That's our 11. I have it written here, but then we also have underground 1.5 inch PVC. So I'm gonna add it here because we got to put it in here anyway. And let's do this one. Control C. I'm going for my takeoff. Control V, and now I have to make it. It's 1.5 PVC. And it's not going to be the same price or labor. I have to fill that in. And so write it down here on my piece of paper, 1.5. And we had 11.5, so I'm going to say 12 feet of that. We're going to fill in again all the conduit and wire totals when we're finished, except for MC cable, because whatever that is from our takeoff is what it is. It's not like the home runs where we have to do extra math. And so the next one is 1.5 conduit that is not PVC. Highlight, insert row, and then we're going to highlight that, copy it, Control C, and then place it here, Control V. V is in Victor. And that is not PVC, that's regular. And I'm going to write it down here. 1.5 regular, and we have 32 linear feet of that. And again, we'll fill that out later on the estimate. Next, power wire, which is our MC cable. Power branch circuits, that's MC cable. We have 161 linear feet of that. So we can knock that off. And now power home run is 290. So I just have an input here for 294 linear feet of home run for the power plant. That won't get filled in here until we get all the home runs added, do all the math. Then we'll fill in all of the wire and then all of the conduit. Now we are going to junction box for the power plant. Junction box, let's see which one do we want to use. We can use that because it is a single gang, so it's one power. And there's one of those. And then we want to single gang, one gang, same thing, but we need it for the cameras. We have 6 of those. And we need a junction box that is waterproof. Right here, that's perfect. Single gang J box, and it is the same thing for the signage. One of those. And go back over here. Rooftop unit power. I'm just going to write that down because we need to determine if that's anything other than number 12. So I'm just going to, and we have 36 feet of that. I'm going to just write that down. And we have a GFCI. Waterproof. GFCI. We'll have to convert this one. Add $10. No, I'm sorry. Add 15. 1. Go back here. I'm going back to my takeoff. Yeah, there's only one. And then what did I say? Add 15. So that's $49.80. Same labor. All right. All right, and now the lights. All caps. So DL2. And 31 of those. DL1. 18. We have the MC cable for the lighting plan. Let me say real quick. It's 512. And remember, if yours is within 10%, we're good. Either way. Okay. And then the lighting home run is 44 linear feet. Okay, let's go back to the lights. W2. We have 10 of those. EM1. Four of those. DL3. Two of those. S1. Four. Let's see, EM2. Oops, hit the mic with my ring. 2. And then we always put the occupancy stuff and all the extra stuff. OS wall. Oop, what was that? 1. Occupancy switch for the wall. And then we have a junction box for the lighting. Let's go back up here. Let's see. Let's just use, have to change the price. There are 3. Okay. Junction box for the lighting. And then bypass and override switch. Bypass. Override. Switch. We'll have a third part or a part of the second part for the panel information. I don't want to put everything on the one video. So we have that. And it's actually a timer switch. And I'm going to spell check everything when we're finished. And then the switch bank. And remember, the purpose of this is to, you're going to get the prices from the supplier, so we're only filling in the portion for the labor. This would be part of your lighting controls, all of this, which would be a part of your lighting package. All right, and then we have a keyed switch, key dimmer switch. It's part of the typically. We don't install speakers, but in the event we do, this is where it goes. So let's, gotta borrow a line. Control C, Control V, place it, and then we had 6 of those. Oh no, 4 of those. Okay, let's save that, and P5. Let me go back over here. Okay. P5. One. And emergency. Light. Battery. Backup. And there were 6. All right, so now we're going to clean it up. Stop here and then get the panel information and then get the, do a separate for the pricing for what we don't have here. So we have to get the panel information to fill in this part. So we'll have a part 2, and then the part 3 is going to be filling in the prices using the cost book and filling in the prices. But right now what we're going to do is clean up everything that's a 0 that didn't apply to this project. We're going to clean it up out of this Excel spreadsheet, except for everything in the panel section, because we have to fill that in next. And yeah, we'll leave that there, and all of our lights, and we'll save. And so far, it's almost 7,000. And see, once you add your lighting package in your panels, you know, that's where it's going to come in. But, and then we have to add all of our wire and conduit, but we won't do even this until we do the panel information, because we're going to have the panel feeders. We got to do all of that, figure out where the panel feeders are in relation to maybe if there's a main distribution panel, we have to incorporate that. So we'll do that second. So in this first part, what we did is basically install or modify an existing estimate that we had to correspond to the new takeoff for this new project number 1. We inputted all of the branch circuits or the MC cable, because there's no multiplier there, so we could input that. But we're not going to input the wire or the conduit until we know we have all of it totaled up and all of that. I started the totals on a separate piece of paper from the takeoff. Then we input all of the wiring devices, of course, and input all of the lights and the lighting controls based on the takeoff. And then we're going to come back and do the switch gear and then do pricing. Okay, so this is part of project number 1. Just, use this as your guide to help you input yours. And if you have any questions, make sure you email me. Okay, so in this recording, we're going to quickly go through how we fill in the pricing and the man-hour totals. Now we have the breakers. This is part 3 of our Excel and pricing for this first project for our electrical. Okay, so we have the panel. So we're going to look for the price of the panel. We already know how long it's going to take. And now we're going to really go in here and look for breakers. So we need a 100 amp 3-pole, 40 amp 1-pole, 20 amp 1-pole, 50 amp 2-pole. So let me move this over. Hopefully, out of view. We're going to open the cost book for which you have access to. We're going to go to the electrical
And this is on EMT, so let's go to a search and let's search for breakers. Okay, so let's see. Circuit breakers, 12240 plug-in circuit breakers with about 10,000 amp. Yeah, I think that's what we want. Yeah. So we're looking for, let's start with 103. So let's use that price, 253. So we're gonna put that in 253 over here where you can't see it. But let's put it over here. So we put that there, 253. And then what we need is our man-hour total. Remember, that is the number that is, which one did we use? This one right here? Yeah. And that's the number after the @ sign. So we're going to put 0.2. Okay, so that's going to fix that. And then we need a 41. 2090. Remember, this is bare bones. This is not as if you're getting it from your supplier. This is if you are getting it on your own. They're not bumping it up more than 5 to 10%. Okay, that's how you know you're getting a good bare bones estimate. And then, this is a winning formula. Has been for 14 years, boys and girls. All right, so we need a 52, 4670. And our time, 0.15. And where do we get that from? Where do they get that's industry standard based on the zillions of years that we know that we have been doing electrical. So that's filled in. Now our panel, we have to get that. It's always recommended that we get our panel, switchgear and panel cost, lighting package and switchgear from our supplier. We put it in here. We leave that blank because we've already taken care of all of the man hours related to that up here. Okay, so this bottom is just for our lump sum for our material. Okay, so we're going to leave that blank because we're going to always do that. We can use the cost book for everything else. Okay, so our next step here is to get our scratch paper where we wrote down, and we won't have to do this, we can take that out. Remember, we're editing our Excel spreadsheet. So we're going to delete row. Okay, we're always going to save afterwards. So, oh, you know what? This is saved on another computer, so we won't worry about that now. We'll fix that later. Okay, so our last step, and we're going to come back, and because some things here we had to, because we use an existing one, so we had to edit it. So we went in there and fixed 1.5-inch conduit, but we had to take the price out because it was the price for another one. So that's why we have to now go to our cost book and do all of that. But before we do that, we're going to go back to our scratch paper and do all of our math for all of our conduit and wire totals, because once we have all that filled in, then we'll go to the cost book, fill in what's missing, and then we're going to have our total final price for this project number 1. Remember, this lighting install only, so we always give each of the fixtures an hour, and our lump sum for the material is down below with the switch gear. Okay, so that's our last price. So bare bones so far, $8,474.28. So we have to come back, and when we get our switch gear, we got to put that in there in this position. We get that back from our supplier, and then when we come back in our next video, we're going to have all of these totals. Okay, for the conduit and the wire, we'll have all those totals. And then we'll be done. We'll come back to the cost book, fill in any material cost, labor that we're missing, and then we'll go from there. So look for the next step, and This is step by step. This is the most important part, right? Producing this estimate. So next step, we're going to fill in that missing stuff and get our final price. And then we will discuss how, in terms of this overhead and profit, how I've always been able to recommend different things to my clients depending on how their organization is built. If it's a mom and pop, this is going to be different. And the labor is going to be different as opposed to if it's a big corporation. So you want to come back for that. So make sure you subscribe. Please do. I never ask, but please subscribe and hit the bell notification. If you like electrical estimating, I do have a separate channel solely for electrical estimating where all new things, stuff you haven't seen here, will be there. And that channel is called The Electrical Estimator. So look for that also and subscribe. And there we'll be giving some one-on-one, 45 minutes at a time. I'd love to teach and make people, to show you, especially electrician, you can win. You can win. You just have to have a winning formula and a strategy and use it the same time every time. So please subscribe, hit the bell notification, and I'll see you next time. Okay, in this short video, here we have gone ahead and inputted all of the breaker information as well as the panel information from the takeoff. So as far as the breakers, we had one 100 amp 3-pole, we had one 40 amp 1-pole, and we all counted that all from the panel. And we had 16 of the 20 amp 1-pole and then one of the 50 amp 2-pole. And so here, I'm going to open it up a little bit. So we'll open it up. Now, the next short video is going to be us going to the cost book, online cost book, and getting the actual cost and then the man-hour units. L is a 42 position panel. And I know that the typical man-hour that they give to install that panel is 15.1 man-hours. So I already know what it is for that one, but we will go and see if we can find a good enough material cost for that panel. But it's always advised that we get that directly from the supplier and then put in the lump sum amount down here. But here we're going to go ahead and always make sure we have all the labor man-hour information in there. So we're going to go to the cost book to find the cost of these breakers, as well as, because we can use the cost book for the breakers, even though the supplier will give you the breakers too, but you, again, the cost book's going to give you the bare bones cost. So you always want to use that first, compare it to what you have or what you're given. And that's why it's crucial to make sure you have more than one supplier. Okay, and so this is the switchgear information. And two, looking at the plans, there is no indication of where or the distance from the panel, okay, to the main distribution. Okay, this gives us, I think it gives us a distance. So we'll have, it says no more than 8 feet. No, this gives us a distance. So run 8 feet. Okay, so this is our single line. So from the single line, it's going to give us our wire and conduit runs, or the type of conduit and the number wire that we need to use for the assembly, right? We're going to get that always from the single line diagram. But in this case, it's not showing us the distance between, any distance between the meter, okay, and the new panel. And so what we've done is just assume that we are going to give it an allowance, because you always want to give it something. We're going to give it an allowance of 100 feet. And so what we're saying here is 100 feet of 2-inch, 100 times 4 of this wire, and then 100 feet of number 8. And that's what we're going to end up filling in. And that's the last thing. Oh, look at me. That's the last thing we need. We have a lot of stuff going on over here. That's the last thing we need to fill in all of our wire and conduit totals for our estimate. So that'll be video number 3, and that'll be the last thing. So look for that coming up shortly. If you have any questions, make sure you review it. But again, in this video, we are concentrating on going from our takeoff to filling in everything that applies to this estimate, editing our Excel spreadsheet and doing it in a way that it's easy and it makes sense. All right, so any questions, let me know, but we're going to go on to the next step.
Hey everybody, this is Stacy, and thank you for joining me. In this video, and this series of videos, we're going to discuss electrical. In particular, this restaurant weekend called Dave's Hot Chicken. And so we are going to go over my 3-step process, right? We always want to do the first step is the very accurate detailed takeoff, and that's what we're going to do now, but we're going to go over it specifically for electrical and specifically for kitchen, and what we need to think about and how we need to approach it when we do the kitchen. So I hope you'll join me for this and the other 2 parts, where our 3-part process is 1, the takeoff, 2 is pricing. We're going to go over the cost book and how we use it to determine our man hours and also our material costs. And then we're going to do the final step, step 3, which is also always the professional Excel spreadsheet that we have designed specifically for electrical, that shows everything, and it shows the quality of your takeoff and the work that you put into it, and it always produces a quality estimate, and you're always competitive. So if this is something that you do, please make sure to subscribe, hit the like button and the bell notification. That way when I am doing only electrical, which we do everything, meaning all of the trades, all of the divisions, all of the aspects of the trade, including safety, you'll make sure to join me. So let's get started. So, on the electrical set for the takeoff. So we know when we have an electrical set, we have a couple of things we need to look at. We have to do the takeoff on the lighting plan. We have to do the takeoff for the power plan. We have to look at the single line diagram. We have to look at the power panels and all of that to do the count. So there are a lot of different things that we need to look at. And when we're talking about a kitchen, the power plan is a little more complicated. You need to think about it in a different way. You need to have a plan of attack when you're actually doing the takeoff for any kind of kitchen, for the particular reason that kitchens have different types of equipment as opposed to like an office. An office may have different types of equipment, but it's like printers and, it's a lot of printers and a lot of scanners or whatever. But when we're talking about a restaurant, we have coffee machines and fryers, the things that we don't even see that they use to process fast food. All of those types of equipment they usually have different wire configurations, meaning the power feeder for that piece of equipment isn't the standard 2 number 12s and 1 number 12 ground. Usually it's something different. And so you need to approach it with that perspective and knowing that when I look at the power plan, I need to have a plan of attack. And so I'm going to show you my plan of attack that I perfected over time. And remember, every set of plans is different because every electrical engineer designs them differently based on their likes and dislikes on symbols. And usually the standard symbols are used, but sometimes they use different stuff that they like or things that you may think is, it's one thing, but it's a combination of a couple of things. And you have to make sure you look in the symbols list as well. So electrical is the hardest, in my opinion, other than maybe structural, but structural is not hard other than time consuming. But when we talk about hard, we're like, you need most of your time. You have to have a very good eye for detail, and if it's just going to take practice. The more you do like anything else, the better you're going to get. So let's look at the takeoff. So this is part number 1. This is for the takeoff, and if you are interested, I do sell study modules that are set that are similar to this, that gives you all the details first about how to estimate a particular trade, and then I give you sample projects. So we'll give you a school, we'll give you a recipe, we'll give you whatever you promise to use, and increasingly hard. So you can do it. So here we go. So it really depends on your time, but I always like to start with the power plan first.
so many home runs that you have to really take your time and do a kitchen estimate and take your time. So I like to start with the hardest stuff first, which is the power plant. So let me turn off some of the lights, and then I'm going to go through my kind of plan of attack and explain what we're looking at, and the best way I think would be to do any kitchen. Hope you like the music. Just kind of makes it better, I think. As long as you can hear me and more me than the music. It's supposed to stop when I talk, but in this echo mic, we're gonna get one new one for our birthday. All right. So what are we looking at? Now, when we look at a kitchen, it's going to give you a way to determine, or it's going to mark out the kitchen equipment. And so these ovals here represent, there's a schedule somewhere, I'll show you. And this is a very bad way to do it, okay? Because this is the equipment list, but for the electrical, this doesn't really help us because it's giving us the shelves. We don't care about the shelves. You know, we do care about the walk-in freezer and cooler to the effect that we have to power it. And so it would be nice to know what wire configuration these pieces of equipment require, which this equipment list doesn't give us. And so this is going to require that the electrician do a lot of extra work that the estimator can't do, other than measure the lengths. I'll give you the links from the walk-in cooler, walk-in freezer to the panel that it's connected to. But as far as the wire configuration, meaning number 12, number 10, number 8, it has to be noted somewhere else. And it's probably, I can't remember. But those are things that you think about and you look at when you're doing an estimate for a kitchen that has tons of equipment. So they threw all of the equipment all on one list. So like the faucet, I don't care about that as the electrician. But seeing these numbers on the left are the marks. So those are the numbers that you're going to see in that oval. Okay, so let me try to find something related to electrical. There we go, under counter refrigerator. Okay, so 21.1, there's an oval somewhere with that number in it, okay? And the good equipment schedule will have just the electrical equipment on it. And then it will also tell you the outlet, if it's NEMA 515P, whatever, the specifications. It'll give you something more detailed for you to use other than in this set. It's just giving us giving the equipment tag and the standard representation for the outlet. So if it doesn't tell us here it's a NEMA or whatever, and it doesn't tell us in the equipment schedule that it's some kind of specialty outlet, so I can differentiate it from general purpose outlets or from the ceiling receptacles. Because these number one is telling me something, and those are the keynotes, right? So that tells me what to do, and then these identify what equipment is connected to that outlet. Okay, and so what I tell everybody, if you're new to even estimating, if you buy a module, you'll be as almost as good as me, because I'm only good because I've done it every day, 10, 12 hours, sometimes 16 hours a day for the past 14 years. And it never said no to any type of estimate, because if you have a set of plans and you have a good takeoff software, which this is, you can do any estimate. You have a good way of determining cost, equipment cost, labor cost. That's called a good cost book. And so when I talk to a lot of new contractors who may have like they call the great resignation. Well, I did that 14 years ago with Bush messed up it. Oops, sorry. I did that 14 years ago. Now, because of COVID, people are doing it or have done it in the past 2, 3, 4 years. And so a lot of new people, new contractors are going out on their own. But, they're getting the work because they're doing it too cheap. Because this is the part that they're missing. And so it's like, okay, get a module. I'll show you what to do. Step 1, step 2, step 3. You're never going to lose. You're always going to be competitive because this is the way that you do it. The more technical way. You don't guess. If you do it the technical way, this step 1, step 2 that I'm showing you, this is step 1 and a lot of talking in step 1. You'll always be close. And over a while, over time, I'm a nerd, so you have to excuse me, the law of large numbers are going to kick in. So the more you send in bids, over time, you're going to start to win. And it's just going to happen that way. And of course, over time, you're going to know how to do the estimates better. Because the ones you don't win, you're going to try to figure out why you didn't win. Okay? And so if you're going to do this for a living, if you're a contractor for a living and you're trying to make your own way, bidding is a part of the game. Nobody's going to just give you work when you just start. And if they do, you're probably doing it too cheap. And that's really that's not how it works. And legally, there's some laws out there that say you can't just it has to be competitive bidding. And so you have to learn how to compete. And so this is the way you do it. Step 1, accurate takeoff. All right. And so these are the hardest. The electrician could lose their shirt if they don't know what they're doing when it comes to pricing because everything is so expensive. Your lighting is expensive. Your wire is expensive. Everything is expensive. And so if you don't know how to price it correctly and make your correct overhead and profit, you're not going to do it. And you'll just basically cut and break even. And, so it just takes time. And it takes, maybe finding people you can trust, and if you're really good, then you'll get a lot of jobs. But this way you'll know how to price it to where you're not giving your labor away. You're accurately pricing stuff based on industry standard. That's what we want, right? And then you add whatever overhead and profit feels comfortable for you. And I'm really talking about to the people, excuse me, like myself that are self-performers. I'm not talking to big corporations that, I really focus on mom and pop people, folks that do the work themselves. And they don't have time to give a good detailed estimate, but they need the work. And so you hire somebody like me or you learn how to do it yourself slowly but surely. You know what I mean? Okay, so restaurants, I'm going to always show you the equipment. Your challenge for the estimator is to say, okay, is it a standard 2 number 12s and 1 number 12 ground? A couple of things on the plan is going to show you it is or it isn't, or just for pricing purposes, you can assume that it is. Okay, and when you see that the home run is going only to one position on the panel, see, and this is a representation of some kind of specialty outlet. But again, nothing on there tells me the spec, what type, what's the specification for it, other than it may be orange or something. But if you're in the trade, if you're an electrician, you probably already know, right? But me as the estimator, I'm just going to say specialty outlet as opposed to one of these, because these are both outlets, but they're different. And so that's the detail you have to make sure you acquire, or, the eye for detail, which is real simple. I mean, does not look like that. So it's different. But over time, you'll learn your symbols. Okay? And we have, it's all equipment. But if you see that the home run is going to only one position on the panel, you can probably assume that you're using 2 number 12s and 1 number 12 ground. And if not, then hopefully it'll tell you somewhere else what the wire configuration will be. And if it's for the mechanical set, chances are there'll be somewhere on the panel or somewhere to tell you what you need. Single line diagram. Okay, and so what we do, and I'm just going to go in the detail that I did do the takeoff. And so I'm looking at all the junction boxes. I'm counting all those that don't tell me something else. So I've read those. And there are more junction boxes, but like these, because it's for the cooler and the freezer, I broke those out separately because they have to be probably, explosion proof or waterproof, especially, if you do gas stations and stuff. Keep in mind, everything there has to be explosion proof, and that is a definitely increasing material cost. Just thinking about that. But these definitely have to be, waterproof, freeze proof, or whatever, as opposed to ones that are outside the freezer. Okay, and so what did I do? The next is the GFCI. Ones that told me that they were that. Okay. So that was 2, must have been 2. Keynote 2. So it told me. Okay, I'm going to pull those out because it told me. And then integrated ground, quads. Okay, you get the point. And so that's what you're going to do. And so I'm going to add all my bubbles. Then we had some outlets that went in the window, duplex. Window. Okay, but yeah, it told me. Okay, so the main thing is really make sure you follow all your keynotes specifically. And you see that you could have one keynote in various locations. So pay attention to that too. Alright, so we fill it in. And then I did the power wire where we can use MC cable. And that's usually all the branch, all the these. As opposed to the home runs. Those always have to be your whatever, number 8, number 10, number 12. And so that came next. And special receptacles for 20 amp, I think. Because it did say that all of the kitchen receptacles have to be 20 amp as opposed to something else. So I always want to, when I do the takeoff, I always want to give the electrician or whoever, the framer, whatever, as much detail as the plan specifically tell me. Because that's their trade. They're going to definitely know more about the details of that, but at least they'll know, okay, these are different from those, which are different from, because the ones in the ceiling, in the window, we add additional costs for the support that it takes to have it in the ceiling as opposed to in the wall, that kind of thing. So that's why we always like to pull out the detail, because when it comes to the labor and the material cost of it may be different from the standard. And you want to make sure you pull that out and let the electrician know, and then they can decide if it makes a difference. Okay, so junction box, and the toggle switch for the fire system, and everything else. Big box for the freezer cooler. And then we went into some links, because that we don't see. But we know that there is a vertical measure of the conduit and the wire going up and down the walls, okay? And so we had 10%, unless it's one. If we only have one run, say for instance, the power, when I say run, run is the distance of the length of the wire, the conduit assembly. And when we say assembly, right, it's the wire and the conduit. That's the assembly. We can price it, we do display it on the estimate separately. How many linear feet of each type of conduit and how many linear feet of each size of wire, size of type of conduit. But the assembly is, but we don't price it as an assembly. Only the MC cable is priced because it is already a cable. It is already assembly, right? There's nothing to put together with that, and the MC cable has a certain configuration within it already, and that's what we use for these bills. Okay, so keep in mind. So for the rooftop units where we don't have a whole lot, maybe it's just 30 feet from the roof to the panel, but we do include 10 feet for the vertical measure. But that's only in the case where we have only, one power run for the exhaust fan. Yeah, we will include 10 feet to go there. Okay, but in the case of home runs, or when we have a lot, or when we have 500 linear feet or whatever, 200, we just add 10%. That's enough. That's my rule. So you can use that for you. But it makes life easy, especially when you're trying to produce a lot of estimates. Alright. So my home runs. We have two panels, panel A and panel B, and I like to always run them separately. So I look for a run that indicates which panel, and I'll run those separately, and then I'll do the other panel. So I did all the A's, let's see. So all the A home runs, I'm gonna light them up real quick. Okay, so yeah, it gets messy. But what I do is I start closest to the panel. So I probably started here. And went to A. Right there. And then the next where I see an A, I go there. Then I took off all the A's so I wouldn't get confused. And then I'm gonna do all of the B's. Okay, remember I was saying sometimes it is or not number 12. If the home run is going to more than one panel, it's probably not all number 12s or maybe 4 number 12s. It is A's and it doesn't tell me, so I'll just, I'll let it be known, but I'll still use what I should use. Okay, that's that. And so the B ones are there. So everywhere there's a B, and same concept. I start with the B's that are closest to the panel. And so keep in mind, I'm not the electrician, right? The electrician may run in a different way, but your job as the estimator is to give an accounting for what is realistic. If I ran it this way, it would be the way that it should be run. It's not like, I'm accounting for every home run, whether I run it this way or I do something crazy and run it like this way, but I'm not going to run it in an unorganized way. Okay. I'm going to run it as organized as possible, and then the good thing now in 2023, you can give your client a copy of the takeoff, so if they think that's reasonable, then they'll be happy. Or they'll at least have an understanding of how you came up with the number. That's most important, so they can add to it, subtract from it. But at least you got a good representation. So that's the takeoff for the very complicated power plan for this project. Now we go to the very easy these are different. That's the emergency landing. Okay, so really with this, just count, and measure. Okay, and so once we counted everything, just all the lights, count the lights and switches. So now I'm going to read what number 6 told me, because this is the cooler. Okay, so on power plan, it told us about how we're going to power it up. The power was here on the lighting plan. It's telling me how many lights they already wired, lights that come with it, and then I just have to connect it to this junction box and the switch. I probably provide or it may provide the next one. Okay, so we add that and some other switches that we have. So as long as you just have a good counting everything that's here, have some string lights, so have to do those too. And then I started the big job of measuring the water. Simple. Just follow the lines. You don't have to do anything other than that. And then the home runs. And all of these home runs on Japan are basically clean. So, the lighting plan is relatively very, very simple. Right? So, we have a big switch to install, and then our home runs. Just in the neatest, most possible way. Okay. And then last, always we have the data plan. And see, this was kind of bad because it doubled up some of them, so I didn't count them. Okay, so I'm gonna count those for our, this is for our data, phone connection, computer connection. So our high voltage electrician will provide the junction box and then the conduit only into the city. Okay, and so have to account for that as part of the takeoff. And then the roof takeoff, that's separate. So here, it had a little contradiction. On the notes, it gave one different wire configuration, but here on the actual plan, it gave this. And so we went by what was on the plan. Okay, so that's all home runs. And of course, the mechanical equipment is going to give you what the wire configuration should be. And so you need to make sure. And if it doesn't, it's usually, something you need to check out. And of course, all of your disconnects for your mechanical, you need to account for them. If it's a piece of mechanical equipment, there is a disconnect for it, and also a breaker in the panel. But you need to make sure the electrician is providing the disconnect, or if it's coming with the equipment, if it's new. Okay, and so that's one thing to make sure. So that's another takeoff. And so here, we're on the roof, right? And so remember, I was saying before, if you're running one home run, meaning we're running a home run for exhaust fan 1. We know the panels are basically right here in the building below. down. Okay, so always keep that in mind, because again, we're only running one run for the ice machine. And so I'm not just going to run it here to the top of the roof, because that's the only one I'm running. And I don't really want to add 10% because that may not be enough or it may be too much. But I know that 10 feet will make it, because I know the typical height from this roof rafter to the floor is about 10 feet. Depending on the building, but you want to check that too. But to the panel, that should do it and not make you overdo it. You don't want to overdo it. Okay? And so, the last part of your takeoff really is to look at your single line. Okay? Single line shows us all the power components and lighting control. You have to go back physically to the power plan and find the physical location and measure the physical location from your power plan. Okay, and we saw that I believe it was like so 26 feet. I measured that already from the power plan, 26 feet. And I think I just gave that 10 feet, even though they're right next to each other. Okay. So that's part of that takeoff. So 26 feet, whatever. Here, what's 3? It's the assembly for that power feeder. So what's 3? 3 is new 2 runs. So I had to do what I say, 26 feet. I had to double it because we're actually running 2 of them. So really 50, you know? So 50 times 4. Gotta make sure that's right. I do so many of them as I wait. 4, 3, the size of the feeder, and then the ground, and then the size of the conduit. That's for that, and then it doesn't take years, so it's probably just number 12 and number 12. It'll show you lighting contactors, okay, and the lighting control should be connected. That'll be on a totally different detail. Okay, but last part of your takeoff are all of your breakers. So you go to your panel, 21, 21, 21, 53, number of poles, size. So that's your detailed takeoff for an electrical set for a restaurant. And the key, the thing that you need to think, okay, I have a restaurant. Okay, and this is Dave's Hot Chicken. Okay, this is not even a restaurant. Imagine if you had a real big, full service restaurant. You would have so many more pieces of equipment, so many more panels, so much more stuff. Probably the lighting control will have a couple panels for itself. If it's a real nice place, they'll have so many different types of lights, specialty lighting. Okay, so keep that in mind. So this is a small place. So your first thought when you have a kitchen, the first thing I'm going to look for is the equipment schedule. Because will I have a long, difficult road to determine all of the specialty outlets from the general purpose outlets, okay? So this is part 1 of our 3-part. This is the detailed takeoff for an electrical set for a kitchen. And so in the end, we hit our estimating tab, and it gives us all of everything we added up all together, all of the links. So now we go print this, and step 2, which we'll be coming to next, will be going here, pricing. Okay, so we'll go to our cost book, we'll open up electrical, and anything that we don't have in our standard Excel spreadsheet. That's step 2. We'll be back for that one. Step 3 is our specially designed Excel spreadsheet for, and this is actually the estimate. So I need to check this again, make sure. just for safety's sake. Yeah, that looks right. 320 linear feet. Okay, that's the thing that bothered me. I'm like, yeah, that's right. And that's the final estimate. So we're going to go over that step 3. All right, step 2's on its way. Please subscribe, like, hit the bell notification, and let the construction queen know what you want to know. I do everything. Leave in the notes. I need underground utilities. I need to know how to do square yard totals for excavation. I need a safety plan, and you're going to get a violation. Okay, don't get a violation. See you next time. Hey everyone, I hope you're doing well and having a good Saturday. Let's work on what we need to do for our electrical estimators for our wire and conduit runs. Okay, we can count lights all day, it's no problem. We don't need help with that. But when it comes to running the conduit and the wire, look for the queen to give you expert advice. And yes, I am the queen. I lost a subscriber because I said I want more women in construction. How ignorant is that? Have a wonderful day. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and I have a student that's asking me a lot of questions when they should just take a class on electrical wiring techniques. And I have to say, I'm not an electrician, but I'm an electrical estimator. And so if you have questions on anything other than, experience is going to give you a lot of clues, and knowing how to read the symbols and asking a lot of questions, and Google is going to help you a lot. But 14 years of doing this, making a lot of mistakes, that helped me a lot. And so there's no one that's just going to learn because I'm good. You're not going to be as good as me, no matter how many times you listen to my work. But experience and time is going to make you good. Estimating is an art. I cook. I didn't always used to know how to cook, but when I had kids, you got to know how to cook or be very, very wealthy if you don't want to cook, right? So over time, I learned how to be an excellent cook by taking my time, getting books, asking people. Same thing with this. I have a degree in electrical, so that kind of made it easy for me to read plans. But to do estimates, it's an art, and you have to ask people that know. You're an assistant to the electrician. You're not the electrician. If you're an electrician, you already know these questions that you're asking me, because those are electrician related questions. And so what I'm going to show you here is just what I normally do on a regular basis. When I get a set of plans, this is the standard. I let my contractor know this is what I'm doing, and communication is key. So when you're doing estimates, if you can give someone a video of it, that'd be a very good thing. All right, so let's get started. Let me get everything ready and let's get started. Now, this is the power plan, of course.
right? And so I'm going to take everything off of here except for the electrical wiring. And again, I'm just going to give you what I do. And if a lot of time it really depends on the quality of the plans, how much information you have, and how good, as far as notes. But when it comes to the wiring, there are 3 scenarios. Okay, there's the home runs. That's 9 times out of 10, the home runs are going to be 3 number 12s, right? Hot, cold, neutral. So it's always going to be 3 for the home runs. When you have the basically daisy chained components, right? They're all, and my contractors, again, I ask the ones that are doing the work, they know what they need. So yeah, they say MC cable, we don't need number 12s for these. Unless, again, if you're doing exterior underground poles, lighting, exterior site, that's usually number 10s, 2 number 10s, and then with the home run. Okay, but then you have to look and you have to ask questions, because you are here to assist the electrician. You're not an electrician. And if you're an electrician, then you already know. But your job as the estimator is to look at the symbols and do your best to make a quality decision on what they're telling you. And it's very simple. Okay, so when it comes to, again, to wiring, you have 3 scenarios. It's the daisy chain stuff, okay, and that's usually MC cable. So I just do straight across. They do all of this, right, because they don't want to mix it up with other lines that are on there. But if you're the electrician, you're not doing all that. You're going from component to component. What this means, it cuts it off, because they don't want to show you where it's going, because again, they don't want to confuse you with all of the symbols. But you can pretty much figure it out. And again, this probably would have took me some time to figure out that this and this go together. How do I want to run it? I usually do things very neatly. So I'll run it from here and line that line up to, or as much as possible, line it up to here, here, to there, or just here, and all the way. It really doesn't make a difference, because what you're trying to do is give a good, logical, from an educated guess from what you see here, representation of how much of a quantity of something that you need. Now, the plans are to scale. So when I set the scale, I know if I measure 1 foot or if I measure 10 feet, it's 10 feet. So I don't have to extra guess. You always want to add 10% waste or whatever, but you don't have to do a whole lot other than what you see here. Just like I was telling one of my clients today. When you do an estimate, you're assuming all of the best possible scenarios, not that you got to crawl up under something, that the material's hard to get to the site. You'll figure all of that out once you win and get the site visit, and then you incorporate those new numbers if necessary. Okay, and so when you're new at this, a lot of, especially a lot of my contractors that are new at it, they think, oh, I give them the price, I can't vary, I can't go out of that price. Yes, you can, okay, because they're asking you to give a price based on plans, not on the actual situation. You may go in there and find a whole bunch of extra stuff, or something missing. It's not the way that they say it was here on the plans. And so that's why you add, once you do the work, you do the addendum. Well, you can do addendum before you do the work, but once you've done the work, you've signed the contract, you started, what is that? A change order. Okay, so don't ever be afraid to say, hey, this isn't the same way it was on the plans, and so we need to adjust the price and labor and all of that accordingly, okay? So the 3 scenarios: daisy chain, MC cable, home runs, 3 number 12s, unless it says. Usually the mechanical equipment is going to say something different. And I think this was number 10s or whatever, but this was existing equipment. And then this said add for the adjustment, meaning I guess they moved the rooftop units one way or another. And so all they wanted them to do is add the additional wire for the difference in, I just did from the beginning, because there's no way, again, to say, well, where was it at beginning and where's the end? Meaning,
where was the equipment before we started and what's the difference. That's too much. So identify where the equipment is and then do the home runs to where they need to go. Okay, so again, 3 scenarios: daisy chain, MC cable, home runs, number 12, unless it says something else, and mechanical equipment will typically be something different than number 12s. And then what's the third? Oh, the third scenario is the mechanical equipment. It's going to be something other. The home runs are going to be something other than number 12. It may be number 10s. It may be 2 number 10s or 2 number 8s, 1 number 10. You need to look on. There should be a schedule either on the panels. It really depends on the plans. I've seen a schedule, meaning the list of wiring for the mechanical equipment on a schedule, meaning on a list. I've seen it on the panel schedule on the panel. So it really depends. I've seen it here somewhere. There'll be a panel or schedule for the mechanical equipment. I think there was one. Okay, so what is this? We got to count all the breakers existing, so we didn't have to worry about that. But we had to add all those. Okay, so wiring. Same thing with the lighting. The lighting's even easier. With the lighting, you're going to have all MC cable. Okay, nothing but MC cable. Okay, and home runs. Going to usually what is this going to? Position number 7, and the lighting panel. I believe this had a lighting panel. Position number 7. Okay, so nothing but MC cable. So the 3 scenarios. Daisy chain like that, whether it's on your lighting plan or your power plan, it's MC cable. Make sure now. Oh, is it number 3? It's used. Everything's. For the lighting, it could be now. That's a good question because I had it in a residential. With the lighting, do I need 2 number 12s or 3 or whatever? What I've been told by my electricians, and again, you need to check with your electrician. They're the ones that know the technical specifications of all of this. But my electrician needed 3 because of the switching, the light, 2-way and 3-way switching mechanisms require not 2 wires but 3. Okay, so those home runs, but you want to check your specs, you want to check your electrician. And if nothing else, they're all going to be the same. You can still do your measurements. Lighting home runs, and that's how I break up everything: the power home runs from the lighting home runs, from the mechanical home runs, from the MC cable for the lighting, MC cable for the power. So my electrician can look at my numbers and determine if it sounds right, because they're the professional. If I say I have 1,000 linear feet of number 12 wire, and I have a kitchen, and usually kitchens require a lot of home runs. If I say I only got 1,000 linear feet of number 12 wire and I've got 60 outlets, that electrician's probably gonna know I made a mistake, because the home runs are 3 wires, right? If I've got 60 outlets, 60 positions, having a 3 wire home run, that's way more than 1,000 linear feet of number 12 wire. And so they would be able to say, that doesn't sound right. Or if we have the power components, all of the panels. Where is the panel? It's not with this. Where? Here we go. So if I put everything. And so if they don't see a number 3 wire or a number 8 wire on their estimate, then they're gonna know you didn't do something right. Okay, so let me just give you the almost final overview of that what we did. Okay, MC cable, additional, see, we had to look at the details for the lighting because some of the lights required additional
wire from a box to the light. Okay, so we had from the box to the light, and then the MC cable for the whole system. So had an additional. So I mean, this stuff is really an art. But what you always want to do is don't put more than what you see on the plans. Okay, whatever's on the plans is what it is. Okay, so let's see. Let me just fill in the wiring. So I even did the water heater because that was a different from this to the panel. And then I added an additional 10 feet because I don't know why, just for fun. So I'll never be under, right? All right, let's see. Oh, no. Yeah, that's the water heater. And always do the wire last. Oh, I just said I was going to do more. I'm not. All right, so following all the daisy chains. Might miss one or two, but I always add my 10%. And this is still in review. So yeah, that's how I did that one. Because we know those two are connected. Okay, so that's the MC cable situation. And then the home run situation. Okay, so what you're trying to do is you want to give your electrician a, not exact, right? But not under. So if I had to physically go in there as the electrician and run this home run, and these plans are to scale, well, yeah, I got to connect it here. Now, I do the neatest, most possible route. You know, I mean, this is my choice in route. But if you've chosen another route, I don't think you'd be much off. As long as you're not doing circles and you do the most efficient thing, the most efficient and neat. Because you got to remember, there may be a specific way they want everything run. If we've got a lot of electronics, like in a police department or even a bank or a gym where there's a lot of a gas station, you may have the cable ladders, and they may require that you run it a certain way. But for something like this, we I just do it the most efficient way that looks the best and the neatest. Okay, and that's pretty much that. So your 3 scenarios daisy chain, when you see that, yeah. And then sometimes they don't give you, okay, that's when you got to grow up, okay, and learn a little more. Because sometimes they won't give you these lines. There'll be nothing there. And then they'll have one here saying where it goes. Well, and then it'll be a kind of a pattern. You can figure out, oh, okay, that's what they're doing. Or they'll have a lot of office buildings, okay, where they'll have, every 10 feet or whatever. So they'll have 5 outlets or whatever in each office, not building, office building with different small offices. Well, they have 5 outlets, 1 on each wall or 2 on whatever. Well, that's going to be daisy chained together. And then it's probably going to be a home run, or maybe 2 offices daisy chained together in a home run. So in not all cases do they give you the lines to follow. Okay, so that's when you got to grow up and ask some questions and just make some mistakes. Okay, so what else? I think that's it. If you have any questions, you can take a class, and I do have Zoom tutor sessions, 30 minutes, $25. We go over your set of plans, any questions that you have, and after 4 sessions, you get 1 free, so you'll get 30 minutes free. So for $100, you'll get an hour and a half. That's not bad from a queen and a pro. Come on now. You can sign up at education@sfjohnsonconsulting.com, but let me know what you think. Make sure to subscribe. I do all of the trades, but I've been getting a lot of requests for electrical because, it's hard if you're just trying to do it, and electrical can cost you a lot of money if you mess it up. Okay, and so 3-step process, take off. Then you got to have a good pricing software. Okay, the pricing software is going to give you your man hour totals. That's where everybody's messing up. They're not getting accurate man hours, and there's only really one way to do that. If you want to get it based on industry standards, based on construction, so you're not shorting yourself, you need to get a good cost book or subscribe with me. We have, of course, good everything. What I use is Plan Swift. I suggest you get that, as well worth your money. It's probably $1,600 US. But, I tried to rent mine now and stuff. That doesn't work. So, I've never regretted. I mean, one Plan Swift lasted me 8 years. I supported myself 8 years off of it. At that time, it was $800. So if you want to do well, you got to invest in yourself, whether it's your education, your tools that you use, or your teacher, Stacy. So I hope I've helped you, and you know who you are. If you have any questions, education at sfjohnsonconsulting.com. Thanks a lot. Thanks for being nice, and I will see you very soon.